bad boy, I'm just for a pure bad boy sound. Me a bad boy, I'm just for a pure bad boy sound. Bad boy sound. Yeah, bad boy, I'm just for a pure bad boy sound. Yeah, bad boy, I'm just for a pure bad boy sound. Yeah, bad boy, I'm just for a pure bad boy sound.
1 second, Will. We're trying to figure out audio for OBS, making it live.
No worries. I like to say I feel good for one reason. I like to say I feel good for one reason. I like to say I feel good for one reason. I like to say I feel good for one reason. I like to say I feel good for one reason.
Hello, CarolinaCon. We hope everyone is having a good morning, and thanks for tuning in for some excellent talks today. A short update on the CTF. New challenges have been dropped and will be throughout the day. If you have any problems with some boxes going down, feel free to just shoot us a message in the CTF chat. So now for the first talk of the day. Moonwalking Through the Cloud, Continuous Integration, Continuous Disaster by Will. He will be talking to us about some issues and findings that his team came across on a recent engagement of a cloud environment from a major cybersecurity company. And with that, I will turn it on over to Will.
Hello, everyone. I'm Will Alexander, and thanks for having interest in my first ever con talk here at CarolinaCon. I'm currently a red team engineer at Palo Alto Networks. I've got some defensive experience with some SOC work, incident response, and threat hunting. I moved over to the red side because I really enjoy abusing technology. So for the last few years, I've been advancing my tradecraft to become a better operator. My wife and I are expecting our first child in September, and I'm elated to start that chapter of my life. And finally, feel free to reach out to me on Twitter or Discord. During this presentation, I'd like to cover the ins and outs of CI/CD and discuss some notable real-world supply chain attacks to set the tone. Then I'd like to discuss some techniques my team and I use to abuse CI/CD in a red team engagement, which enabled us to moonwalk through my organization's cloud environment. Finally, I'll close out the talk with some DevOps and security considerations being implemented at Palo Alto Networks and general supply chain mitigations. CI/CD is a DevOps methodology used to frequently deliver apps to customers by automating stages of the software development lifecycle. Continuous integration is the process that occurs after a developer checks code into a repository like GitLab or Bitbucket. After making changes, the code is merged into the master branch, which kicks off a build process. The build process creates the needed artifacts, and the code is run and tested with feedback automatically provided to the developer so they can know if their changes broke anything. This process is repeated continuously as all developers work on code for the project. The build and test process is typically executed on a CI/CD runner. In GitLab, the runner is flexible and open source and is written in Go. It can be deployed to bare metal, virtual machines, Docker containers, or Kubernetes, depending on the needs of the developers. The runners are typically ephemeral and short-lived devices that spin up and down only when a build process is executed. I'll talk more about these runners soon. Continuous delivery is the process of packaging the created software artifacts from the CI process and preparing them to be delivered to environments like QA, UAT, or production. And lastly, CD could also refer to continuous deployment, where the process of deploying to the aforementioned environments requires no human intervention. For the remainder of this talk, my focus will be on continuous integration and continuous delivery. Summed up, the entire CI/CD workflow is meant to automate and speed up DevOps while making developers aware of bugs earlier. So there's tons of CI/CD platforms and tool sets, free and paid services in both open source and closed source. And CI/CD is said to have all of these benefits like faster developer iterations and efficiency, higher release quality, and more consistent build processes. Some of these products even claim to lower the risk of security incident by misconfiguration. Well, that sounds like a challenge to me. Well, it sounds like less of a challenge as soon as you introduce a weak link, the human. The threat landscape becomes wide once developers begin introducing unvetted third-party code dependencies or public container images, or even just using extensions for various IDEs. Developers may even be hard-coding keys, credentials, and secrets within projects that could lead to attackers being handed the keys to the kingdom. This doesn't even touch on standard security misconfigurations like overly permissive accounts or faulty firewall rule sets that could play a role in limiting a CI/CD compromise. The SolarWinds breach affected so many organizations because the actors were able to modify code for software updates within the CI/CD pipeline. The Orion source code was modified to include a backdoor, the CI/CD build process was executed, and the software was distributed to clients. Hundreds of malicious NPM packages are being discovered in the wild. The user agent parser JavaScript library was recently compromised with 3 malicious versions, and at the time, this library had roughly 7 million weekly downloads. Attackers operated in the Puriform network for months preparing their malicious version of CCleaner. It was hosted on the official website and distributed to millions of users over the course of about a month and a half before the company was made aware and removed the malicious version. My team set out to determine the breadth of compromise starting from 3 assumed breach scenarios: a single CI/CD pipeline compromise, a developer installing a malicious VS Code extension, and a multi-pipeline compromise. In the first attack scenario, we worked to simulate a scenario wherein developers are including unvetted third-party dependencies within their CI/CD build process. We backdoored a simple Debian package and worked with the developer to modify his code so that the build process would download and install the malicious package from an arbitrary site. We rolled out our attacking infrastructure, which included a payload server and command and control infrastructure in our own Google Cloud environment external to Palo Alto networks. The developer kicked off the GitLab CI pipeline and the build process began. A GitLab runner was spun up, it installed our malicious package, and C2 was established. Because of the short lifespan of these runners, we opted to background our malicious process in order to keep the runner up. It should be noted that developers may notice hung CI/CD jobs, as this process typically takes less than 5 minutes. The runner was deployed in Kubernetes, so when we landed a shell, we were in a pod. Going into this engagement, we researched methods of pod escapes and privilege escalation in preparation. Turns out we were overprepared. CI/CD variables are a type of environment variables that are meant to help developers. These variables can be used to control the behavior of jobs and pipelines, store values for reuse, and avoid hard coding values in code. To an attacker, the runner environment variables provide a wealth of information. There's a number of predefined variables that include important details about the runner and GitLab resources. One specific variable that we found valuable was the CI job token, which can be used as a form of single-factor authentication to query the GitLab server API endpoints. Any request made using this job token run with the permissions of the pipeline owner, which is the developer in most cases. This token is not local to the project being worked in. Whatever the developer has access to, the token can be used to access it. It's important to note that this token is only valid as long as the job is running. But since we hung the pipeline, we had some additional time to use it. And so we set out to determine what the developer had access to. The GitLab API documentation became handy very quick. We began by listing out which repositories the developer had access to, then used Git to clone each of them to the runner, then moved them locally. Just as a proof of concept, we automated this process with a tool we dubbed Git Labrador Retriever. We successfully exfiltrated more than 400 projects in minutes. Compressed down, it was just over 4.5 gigs. The developer must have been very busy to work in 400 projects at the same time, or this is just a typical case of an overly permissive developer account. Funny enough, we crashed our C2 server on the first exfil attempt because the data was too large. From there, we opted to use Updog as our exfil server. We began perusing through the source code offline to further our attack, and it wasn't long before we found hard-coded credentials for an Active Directory service account without multi-factor authentication in place. We used this account to access the internal Jira server and scrape thousands of tickets from our foothold on the runner. After that, we authenticated to GCP and AWS, where we had read and write permissions to numerous projects. At this point, we were happy with our level of access, so we moved on to phase 2 of the operation. In this scenario, we modified a legitimate VS Code plugin to include another binary that would establish C2 when the plugin is installed. During our research, we found that it was trivial to craft an identical looking extension. The screenshot on the left is the legitimate extension, while the screenshot on the right is the malicious one. And as a bonus, VS Code extensions are a great form of persistence, since each time VS Code is started, it kicks off our payload. We worked with a different developer to install this plugin, so there wasn't a ton of overlap with the first attack scenario. Once the foothold was established, and after some initial reconnaissance, we discovered the developer was using the GitLab workflow VS Code extension. With this plugin, devs can browse repositories, create merge requests, and manage CI/CD pipelines all from VS Code. But to do any of this, the plugin requires a GitLab personal access token, which is stored in a database file on disk. On macOS, the VS Code database file is stored in the application support code user global storage directory. We yoinked the database file and used SQLite to carve out the token. We then used the personal access token to query GitLab for group and project variables that the developer could access. Group and project variables are custom variables that get passed to runners during the CI build process. As expected, we found numerous credentials, secrets, and tokens for a number of other CI/CD applications, including an Artifactory service account. At this point, we had rights to upload packages to the internal Artifactory that could be used for further compromise. We also had permissions to modify existing dependencies for further pipeline abuse. Stepping away from Artifactory, we returned our focus to the GitLab personal access token. Again, armed with the API documentation, we were able to commit changes to an existing repository and execute the CI/CD pipeline, which landed us another foothold on a GitLab runner. Rinse repeat the first attack scenario. Back on the developer's host, we began exfiltrating GCP credential database files, some of which belonged to CI/CD service accounts. Using the gcloud command line utility, we authenticated with the stolen tokens and found we could access numerous GCP projects, storage buckets, and Kubernetes clusters. Google has this great feature called metadata managed SSH, which creates a public key and attempts to add it to any compute instance you try to connect to. So with the right permissions, we began spreading into numerous VMs that are not internet accessible by using the gcloud compute SSH functionality. We didn't really execute groundbreaking techniques for GCP post-exploitation, but we did lean heavily on a blog post from GitLab's Red Team, which is a great resource for privilege escalation and lateral movement. Our typical process was to authenticate with a set of credentials, list accessible projects, then enumerate and document accessible services and service accounts, enumerate the permissions of other service accounts, SSH to compute instances, seal more tokens, and repeat the process. By the time we exhausted all of the Surface accounts that we could authenticate with, we had access to hundreds of GCP projects. At this point, we wanted to use our beachheads within GCP to proxy traffic internally. We crafted a custom Docker image, which used Stunnel to mask SSH traffic as TLS in order to evade firewall detections. This container was deployed to a few VM instances and was used as an ephemeral space to run scripts and interact with internal web interfaces. Eventually, we found a free IPA LDAP server deployed in GCP that allowed us to dump a couple thousand Active Directory usernames and groups. We also used this LDAP server to further validate credentials found during past exfiltration. Before calling an end to this attack scenario, we returned to the C2 from the developer's machine to try to steal his Okta session token. We restarted his Google Chrome session in debugging mode and queried the debugging port. We were able to obtain the Okta token, which was then replayed using Burp Suite, which bypassed MFA and dropped us to the developer's application dashboard. For the final attack scenario, we worked with a developer to modify a CI template so that it would include a custom Linux binary that we wrote. CI templates allow developers to incorporate their favorite programming language or framework into pipelines. Instead of building pipelines from scratch, these templates simplify the process by having parameters built in. The template was used as a way to simulate multiple developers using a single compromise dependency. When the pipeline started, our binary was downloaded and executed. Because of our previous attack scenarios, we knew the runner environment variables were a trove of loot. Our payload simply exfiltrated environment variables to an external web server via HTTPS, and before long, we were sitting on hundreds of keys, API tokens, and Active Directory service account credentials. Without much effort, we gained control of more than 4,000 projects within GCP, which likely would have turned into a full organization compromise given the time for reconnaissance and lateral movement. Instead, we turned our attention to other credentials, one of which was an old GitLab bot account with single-factor authentication. We logged in and we found the bot was a GitLab admin. Although being an admin, the bot didn't have a ton of access to do non-destructive activity. There were no permissions to view or modify repositories, so we used the API to determine the user with the most privileges. The API has an admin-only impersonation function that essentially crafts a personal access token of other users without alerting said user. So that's what we did, and that's how we owned the entire GitLab instance. Although this was likely the largest attack, it was relatively uninvolved. Hopefully, these attack scenarios have emphasized some possible outcomes of supply chain compromises. But these breaches don't stem from a single failure in defenses. There are a number of mitigating factors that we as a red team believe could have prevented the wide-scale compromises. Here are some of the recommendations we made after concluding the engagement. Generally speaking, the top of the list is more upstream and would have disrupted operations, while the bottom is more low fidelity, but still could slow attackers down. In most cases, GitLab runners should not be making outbound connections, especially to health and finance domains that attackers commonly use to avoid SSL stripping. Secrets should not be stored in environment variables. GitLab supports HashiCorp Vault as an external secrets engine. These secret managers should be secured and regularly audited. Don't allow developers to have access to hundreds of repositories simultaneously. Prevent developers from including arbitrary third-party dependencies that have not gone through a code review process. Instead, force devs to use a central artifact repository like Artifactory. Watch for one or a few accounts cloning down numerous projects at once. Monitor highly permissive accounts like GitLab admins conducting impersonation. And there are a few others like checking for Okta replays, keeping an eye on weird cloud SSH events, and regular artifact scanning. But these recommendations may only work in a bubble. Different organizations obviously have different requirements and use cases. The CI/CD pipeline was conceptualized with a developer-first mindset. Speed and convenience are the primary goals. Therefore, it's important for developers and security practitioners to evaluate the threats associated with DevOps. This engagement was my first foray into CI/CD and cloud red teaming, and I really enjoyed it. So I plan to continue research into CI/CD abuse. Earlier this year, the NCC group published a blog with 10 CI/CD attack scenarios. Some of what we executed is covered in their post, and my team is planning to conduct another engagement related to the remaining relevant topics. Hopefully this talk sparked enough interest to have more folks in the industry review their own CI/CD environment. And lastly, I'd love to chat about your experiences with CI/CD. If you've conducted an engagement, went through a security review process, or just want to discuss more about my presentation, feel free to reach out. And I just wanted to give a few quick shout outs. Thanks again to CarolinaCon for hosting and accepting my first ever con talk. Shout out to the 49 Security Division at UNC Charlotte. They're a great cybersecurity club that I was a part of while I was still in school. Definitely want to show them some love. Shout out to Josiah Petekiel, who was our red team intern during this engagement. He's a genius, and we refer to him as Big Brain. And finally, shout out to Richard Penshorn, who joined us for 2 weeks during the engagement and taught us a lot about cloud lateral movement. Thanks.
Recording in progress.
Red light, red light. Red light, red light. Red light, red light. This one coming like dynamite. Good ass girl, better than the rest of you. A good ass girl. No girl take from you. A good ass girl, better than the rest of you. A good ass girl. No girl take from you. A good ass girl, better than the rest of you. A good ass girl. No girl take from you. A good ass girl, better than the rest of you. A good ass girl. No girl take from you. A red light, red light. This one coming like dynamite. Never seen a glamour with such a bumper. From me see a bumper, me know a me and a fit her. Never seen a glamour with such a bumper. From me see a bumper, me know a me and a fit her. Never seen a glamour with such a bumper. From me see a bumper, me know a me and a fit her. Never seen a glamour with such a bumper. From me see a bumper, me know a me and a fit her. Good ass girl, better than the rest of you. A good ass girl, no girl take from you. A good ass girl, better than the rest of you. A good ass girl, no girl take from you. Red light, red light. This one coming like dynamite. Red light, red light. This one coming like dynamite. Red light, red light. This one coming like dynamite. Red light, red light. This one coming like dynamite. Never seen a glamour with such a bumper. From me see a bumper, me know a me and a fit her. Never seen a glamour with such a bumper. From me see a bumper, me know a me and a fit her. Never seen a glamour with such a bumper. From me see a bumper, me know a me and a fit her. Never seen a glamour with such a bumper. From me see a bumper, me know a me and a fit her. Good ass girl, better than the rest of you. A good ass girl, no girl take from you. A good ass girl, better than the rest of you. A good ass girl, no girl take from you. A red light, red light. This one coming like dynamite. Red light, red light. This one coming like dynamite. Good ass girl, better than the rest of you. A good ass girl, no girl take from you. A good ass girl, better than the rest of you. A good ass girl, no girl take from you. A never seen a glamour with such a bumper. From me see a bumper, me know a me and a fit her. Never seen a glamour with such a bumper. From me see a bumper, me know a me and a fit her. Good ass girl, better than the rest of you. A good ass girl, no girl take from gonna come like dynamite.
This version is way from creation.
Prejudice? And who ya try come this? We don't support no racists, no time at all. All the people gonna back them thing there. Follow leave it. Rude boy. We no like easy. Neither no easy. No support no racist. Half prejudice. We no like easy. Neither no easy. No support no racist. Half prejudice. So what? You're not supposed to fuss. You're not supposed to fight. You're not supposed to prejudice. Black neither white. Manipulation is on the right edge of your side. So live only by that are the meaning of life. So put peace above and put war aside. And put yourself in a conscious state of mind. You got to be conscious to survive the time. And you live only fine. You know you're going to survive it on the easy. Neither no easy. No support no racism. Half prejudice. We no like easy. Neither no easy. No support no racism. Half prejudice.
This version, way from creation.
All the oppressor and all backbiter. Discrimination is not work no longer. Yes, we in the ghetto, we use the alcohol. To the skin color, and we can cross the border. No we get wiser and we get stronger. Then slavery chain can't hold we no longer. We coming like a soldier, nothing we come before now. Step on the back of the we coming the big band and Halawa. We no like easy, neither no easy. No support no racist, half prejudice. We no like easy, neither no easy. No support no racist, half prejudice. So what?
This version, way from creation. This version, way from creation.
Rude boy. Rude boy. Come out of the darkness and step up into the light. And put war aside, cause a time to unite. Unity is strength and that we must realize. We're living in a perilous time. We no like easy, neither no easy. No support no racist, half prejudice. We no like easy, neither no easy. No support no racist, half prejudice. So what? Easy, neither no easy. No support no racist, half prejudice. We no like easy, neither no easy. No support no racist, half prejudice. So what?
This version is way from creation. This version is way from creation.
Neither no easy, no support no racist, half prejudice. We no like easy, neither no easy, no support no racist, half prejudice. So what? Easy, neither no easy, no support no racist, half prejudice. We no like easy, neither no easy, no support no racist, half prejudice. So what?
Hear this. Hear this. Hear this. Hear this. Hear this. Hear this.
Watch with her, so we are the girls them lover. I want them a watch with her, so we are the girls them lover. I want them a watch with her, so we are work for the father. Watch whipper, make a well license pay. Watch out, girls them a ask them a wicked them a fast, them a just can't ease off. Girls them a add them a bar, them a scream when Levy let off. When me come, but I am the teacher with this stuff. DJ off the pass, I tell them Levy are the boss. All them a rear, them can't touch me nuclear. Levy in the place, I'm cruising just like a nuclear. All them a rear, them can't touch me nuclear. Levy in the place, I'm cruising just like a nuclear.
Hear this.
Baker well,
Hear this. Hear this.
Baker well license pay. Watch out. Watch whipper, Baker well license pay. Watch out. Watch whipper, Baker well license pay.
Hear this. Hear this.
Girls them a ask them a wicked them a fast, them a just can't ease off. Girls them a add them a bar, them a scream when Levy let off. When me come, but I am the teacher with this stuff. DJ off the pass, I tell them Levy are the boss. All them a rear, them can't touch me nuclear. All them a rear, all them a rear, all them a rear, them can't touch me nuclear. Levy in the place, I'm cruising just like a nuclear. Watch whipper, Baker well license pay. Watch out. Watch whipper, so we out work for the father.
Hear this.
Watch whipper, so we out work for the father. Watch whipper, Baker well license pay. Watch out. All them a rear, them can't touch me nuclear. Levy in the place, I'm cruising just like a nuclear. All them a rear, them can't touch me nuclear. Levy in the place, I'm cruising just like a nuclear.
Hear this. Hear this.
Girls them a ask them a wicked them a fast, them a just can't ease off. Girls them a add them a bar, them a scream when Levy let off. When me come, but I am the teacher with this stuff. DJ off the pass, I tell them Levy are the boss.
Recording stopped.
Hear this. Hear this. Hear this. Hear this.
Baker well license pay. Watch out. Watch whipper, Baker well license pay. Watch out. Watch whipper, watch whipper. Watch whipper, Baker well license pay. Watch out.
For my next number, I'd like to return to the classics, the most famous classic in all the world of music.
Warning, warning, warning. No things is going in. Murder from now to the morning, man. Leave you again from them elements. Everything fine and steel. Yeah, rude boy for real. Shine on the steel. Africa by Bangkok. What we tell them bad boy? It's like this. This a one you wicked. This a one trader. Flying up a skull and make we poor couple head. This a one you wicked. This a one trader. Flying up a skull and make we poor couple head. Bad boy. Get me simple. Two way you go innocent face and with dimple. Tell a boy test and make we see you a go dwindle. Fuck up in a trouble from your fuck up in the general. With no dirty bungle, Jennifer now go entangle. Sometimes me mangle, but I'm one time me spangle. Me wear the chops and me girl wear the bangle. With no informal, Jennifer not entangle. Run about to the sample. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head. It's like this. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head. Can't get the job, can't come in one circle. Me run things, and you know said that a trouble. You never leave it on them like a sample. You never leave it on them like a sample. Me live a arm down street, and I'm a 364. A boy want to test, but then if you come knock me door, brain no stop fly, skull no stop bore like a raging bull. We gone on, this a one you wicked, this a one dread. Flying up a skull and make we pour a couple head. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head.
The most famous classic in all the world of music.
It's like this. Bad boy first shot it in farmer dead. Blood no stop, speaker when no stop. Hey, it's like this. Bad boy first shot it in farmer dead. Blood no stop, speaker when no stop. Hey, you take me simple. True way you go innocent, fierce and with dimple. Tell a boy test and make we see you a go dwindle. Fuck up in a trouble from your fuck up in the general. With no dirty bungle, you never now go entangle. Sometimes me mangle, but I'm one time me spangle. Me wear the chops and me gal wear the bangle. With no informal, you never knock in tongue. You never leave it on them like a sample. Murderer, it's like this. Murderer, murderer, it's like this. You never leave it on them like a sample. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head. This a one you wicked, this a one dread. Flying up a skull and make we pour a couple head.
Too much wicked talk when I done nothing for the youth them. But we look on them and say, too much wicked talk when I done nothing for the youth them. But we look on them and say, promote. Father go and crush it like coach. Encourage them to go shoot. Nah, do not good for the youths. Your wickedness you promote. Father go and crush it like coach. Encourage them to go shoot. Nah, do not good for the youths. Everywhere you go, you bring. Everywhere you go, you bring pain and sorrow. Your wickedness you promote. Father go and crush it like coach. Too much wicked talk when I got nothing for the youth then. Everywhere you go, you bring. But we look on them and say, Father go and crush it like coach. Your wickedness you promote.
Hey guys, this is Scott joining. How's it going?
Encourage them to go shoot.
Your mic is off, by the way, but feel free to share your screen and let us know how much you listen to.
Good deal. Yeah, let me get my earbuds connected. They're not working
Everywhere
right.
you go, you bring. Everywhere you go, you bring pain and sorrow.
Recording in progress.
Too much wicked talk when I got nothing for the youth them.
Champion of the world in this musical corner.
Don't say nothing.
Backward,
Don't say nothing.
backward,
Don't say nothing.
backward,
Don't say nothing.
backward.
True, we are going good and we don't stop running warm. Some little idiot boy won't come try match we call. Go tell the whole of them nobody ring we alarm. Cause from a boy test, I did those you gum. Don't say nothing.
Backward,
Don't say nothing. But let you want something, but man no say you want nothing. But let you want something, but man no say you want nothing.
champion of the world. Champion of the world.
True, we are going good and we don't stop running warm. Some little idiot boy won't come try match we call. Go tell the whole of them nobody ring we alarm. Cause from a boy test, I did those you gum. We will certify. But we them a cry. One thunderball and a heathen die. certify. But we them a cry, one thunderball and a heathen die. We well certify. But we them a cry, one thunderball and a heathen die.
Champion of the world in this musical corner. Champion of the world in this musical corner.
True, we are going good and we don't stop running warm. Some little idiot boy won't come try mash we con. But tell you all of them number the ring we along. Cause from a boy test, I did those don't say nothing. Don't say nothing. But like you want something, but man don't say you want nothing. Where you a go with that idiot flex? Oh, you a go like you want disrespect? Where you a go with that idiot flex? Oh, you a go like you want disrespect? Don't say nothing. 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 Don't say nothing.
Champion of the world.
Big up all our late night crew. Big up all our late night crew. Original drunken master passing through. Them call we the drunken master. No true with us, they go cloud when we kill a snake fish. But me say we better than danger. No matter try test the master, me say don't bother this. Big up all our late night crew. Original drunken master passing through. Big up all our late night crew. Original drunken master passing through. Big up all our late night crew. Original drunken master passing through. Big up all our late night crew. Original drunken master passing through. And I'm a dragon and I'm a bro. Special request to you and God now so. Hear this. Watch out. Where is a teacher with a lip apprentice? For the drunken style, we are the style specialist. We're rougher than the whole lot of this is crazy fist. And if a boy want this, him a run a big race. Chuck it on top, cat when that a dead wish. I will run things when it comes to madness. We fling poison dart, and I know when I miss. Big up all our late night crew. Big up all our late night crew. Big up all our late night crew. Original drunken master passing through. Big up. Call me the drunken master. Big up all our late night crew. Original drunken master passing through. And I'm a dragon, I'm a bro. Special request to you and God now so. Hear this. Watch out. That's why them call we the drunken master. Not so we dust out the monkey and we kill the mantis. We have the eye of the tiger. Me say we broke up the dragon with a karate kick. Me say we broke up the dragon with a karate kick. Chuck it on top, cat when that a dead wish.
Up next, we have Vulnerability Management for Containers by Scott Wilson. Scott has 2 decades worth of experience analyzing vulnerabilities, and today he's going to be sharing with us how he applies that experience to securing containers. Join us as he details the different models and strategies that he can take for securing containers. And with that, I'm going to turn him over.
Hey everyone, this is Scott Wilson coming to you live from Raleigh, North Carolina. I'm so grateful to be here with you today. Major shout outs to the 49th Security Division and UNC Charlotte for putting on this conference. If you get an opportunity to thank one of our conference organizers today, please drop them a little love in the Discord or Matrix channels. They've worked really hard to put this conference together. I am part of the X-Force Red team at IBM Security. We're the offensive security group. So my team is essentially a group of hackers, red teamers, purple teamers, and vulnerability management professionals. And we do exactly what it sounds like. We get paid to break into companies to help them identify their vulnerabilities and put together an action plan with them to resolve those items to reduce their risks. A lot of what I do focuses on vulnerability management, and I've prepared a talk for you today related to vulnerability management for containers. And so I don't need to tell you all that cloud security is kind of the new hotness and has been for a while and will be for the foreseeable future. And more applications are moving to a containerized business model. And that has a big impact on the vulnerability landscape, the attack surface of your organization, and how you need to go about addressing those vulnerabilities. So I'm going to talk to you today about a couple of things. So specifically, I'm going to share some terminology and some concepts to basically make sure we're on the same page with respect to what we're here to talk about today. Then I'm going to share a little bit about the development pipeline. What does that look like? If you listened to Will's talk earlier today, you got some good insight into the CI/CD pipeline, what that is, what kind of attacks are commonplace for that type of setup. And I'll speak a little bit more about that as it pertains to containers and the deployment of containers, and of course, keeping those containers secure and safe. Then we'll go into some different vulnerability scanning strategies. It's a little more complex than the traditional host-based vulnerability scanning methodologies that companies have used for 20 years. And I'll highlight some of those differences, and then we'll move into talk about what kind of products are available on the marketplace, what are their strengths and weaknesses, and how do you go about making a cohesive decision about which tool to use and under what circumstances. It would be difficult to talk about cybersecurity and vulnerability management without at least touching on compliance. And so I've got a few important points about compliance management in the container space as it relates to vulnerability scanning and management. And then I'll sum up with a couple of conclusions, and I've got a few takeaways that you can bring back to your organization to speak intelligently with your team about how to keep containers secure, how to do vulnerability management in that space. So first off, though, let me get a couple things out of the way. This talk is not really a containers best practices talk. That is really another topic altogether. There are a lot of things that you can do from a best practices standpoint, such as putting in a process to sign containers, making sure you don't use root access, layering the images properly to optimize the deployment and runtime activities related to containers. That's not what I'm here to talk about. Really, we're going to focus on the vulnerability scanning, how vulnerability scanning needs to be set up for containers. Likewise, I'm not really going to talk a lot about orchestration. You can't really talk about containers without at least mentioning orchestration, and Kubernetes and tools like it are critical for the successful operation of container environments. I'm going to talk a little bit about Kubernetes admission controllers, what they are and how they can help within the pipeline, but I'm not going to dig like super deeply into that topic. And then finally, I'm not here to make a sale. Yes, I work for IBM. Yes, X-Force Red does have relationships with a couple of vendors in this space, but I'm not here to promote any one particular product. And I'm not here to get you to buy IBM services or anything like that. So let's hit on a few terminology topics, a few concepts, just to level the playing field, to make sure we're saying the same things. What is a container? Well, it's a lightweight, independent, isolated computing runtime that hosts an application. Containers were conceived to be highly portable, and sort of like Java when it was under its early development. The concept was, hey, what if we could write a small contained application that is highly portable, that could run anywhere with, no regard for what kind of infrastructure the underlying hosting system is. And that's what a container really is all about. A container image is simply a recipe for what is built into that container. And so the concept here is you create a container image, you build that immutable unit of software, and then you deploy instances of that into your production environment. In addition to the portability, one major thing containers can provide is scalability. So you have an application, it needs some more horsepower. Well, all you have to do is spin up a few additional copies or a few hundred additional copies of that container image, and you've increased your capability to deliver services to an application or to a service. Now, when looking at how containers are set up and how they work compared to traditional virtual machine environments, you can see in my picture on the right here, virtual machines are essentially a way to share components of hardware across multiple operating system instances. And so you've got your infrastructure, there's a hypervisor layer that is really the meat and potatoes of what virtualization is all about. And that hypervisor allows multiple guest operating systems to share resources on a physical computing unit. And that's great. Containers is a little bit of a different animal because there really isn't a hypervisor. Instead, you've got some kind of a runtime. Most folks are familiar with Docker as a popular runtime environment. And the Docker layer allows you to run multiple container instances on top directly of a host operating system. And that's very powerful because you've been able to eliminate some of the components that cause a lot of churn and angst in the IT management space. More specifically, the guest operating systems themselves can be huge, typically many gigabytes in size. And so each virtual machine that you're running to support an application has a full copy of the operating system. And guess what? That OS has to be maintained, it has to be patched, it has to be backed up. It's not something that you can truly ignore. And by contrast, in the container space, the runtime environment is what provides the abstraction layer. So engines like Docker, Containerd, LXC, runC, Creo, these are all very popular runtime engines that serve the same purpose, which is to share the underlying host OS's capabilities with multiple instances of your container. So a container itself has tons of different layers. At the bottom, you've typically got a bootable file system or a kernel layer. On top of that, there's typically a parent image, and that can be a full operating system, traditionally Linux, or it can be a very slimmed down and bespoke custom created operating system. And then on top of that, there's an application layer, and this is where you'll find things like your MySQL database or your Nginx web server and code like that. And then on the very top, there's often a writable file system for things like logs, access control information, temp files, and things like that. And the bootable writable file system usually is destroyed once the container is destroyed. So you've got many layers kind of working together in concert. This colorful picture here represents kind of the 4 C's model of container security. So you've got the cloud environment on the external layer, meaning what's the security of your data center like? What does that look like to you? And then within that, you've typically got a cluster, which is a family of computing resources to support the container environment. Inside that, you have the container itself, and then of course your code running down at the bottom there. And this presents a lot of challenges because the attack surface can actually be very large if these containers are not managed properly, if they're not put together in a cohesive way, or if the underlying cloud and container infrastructure is not properly secure. So there's a lot of things that can be done here to look at the attack surface, to minimize that, and we'll talk about that in a minute. I just got done saying I wasn't going to talk about orchestration, but just so that we know what we're talking about here. Orchestration is the capability to manage multiple container resources. And Kubernetes is the easiest example to talk about, but there are other tools out there like Docker Swarm, Apache Mesos. There are a lot of different platforms, although I would say Kubernetes probably gets the most attention in terms of its popularity. And the purpose of orchestration is to provide a couple of different functions. Certainly service discovery and load balancing is a key component. The orchestration of different storage components. I mean, these containers have to be written to disk at some point. And so Kubernetes and tools like it help manage where these devices are, where these containers are stored and how quickly they get pulled in and out of production. Things like automated rollouts and destruction of containers once their life cycle is over is important. Automatic deployment is a key feature of orchestration tools because the idea is to kind of ramp up or bring down the number of containers as demand increases or decreases for your application. Kubernetes and engines like it also have the ability, I call it like a self-healing capability. So if there is a container that for whatever reason isn't performing correctly, or if it crashes, engines like Kubernetes have the ability to take that container out of circulation and replace it with a fresh copy. And the idea here is to maximize uptime, maximize service availability, and to generally take people's hands off the keyboard with respect to the minute-to-minute maintenance of running containers in the production environment. Let me talk a little bit about the development pipeline. So Will gave us some good information about that this morning, and what I'm going to say might differ a little bit. Remember, this is just a model. So the continuous improvement, continuous delivery pipeline is a good model that most development organizations use related to planning, building, deploying, managing, testing, and operating their containers out in the real world. So the planning phase of this is more about defining requirements, identifying what your scope is going to be, figuring out which software libraries, frameworks, components are going to go into your software product. Coding is pretty straightforward. Throughout the build, test, and release cycle, you're incrementing releases, you're putting together different use cases and test models and things like that, maybe going through UAT and other unit testing. And then eventually you get into release, deploy, operate, which is, hey, here's my code, it's ready for the world, let me put this out into the production setup, let's make sure it gets there, and let's operate it over time, making sure that the life cycle of that software is appropriate. So nothing you haven't heard before. I'm going to draw a little bit of a different picture of that to talk specifically about the container management pipeline. So I've simplified this CI/CD model a little bit into 4 blocks, if you will. So there's the development stage, which is a lot of the CI/CD stuff I just spoke about. The registry, or the second phase, is a really crucial concept to understand with respect to vulnerability management. The registry is sort of like a repository for your published code. It exists in a space that is before production occurs, and this is from where your orchestration engine is going to draw copies of your image to create and build and deploy a running instance of that container. The runtime, as I've said already, is kind of where the action happens. The runtime engine is what is responsible for maintaining that container, keeping it active, ensuring that it functions correctly. And then at the end, you've got your master node, the host on top of which all of this stuff runs. And it's important to not forget about that phase, because you still have to consider traditional vulnerability scanning, vulnerability management, and all the fun stuff associated with patching and backups and compliance and all that good stuff. I kind of think of the development phase and the registry component as more of the pre-production environment, whereas the runtime and the cloud environment, your master nodes and hosts and things, that's really like the production setup. And there are a lot of tools that are used throughout this 4-step phase. So you've got tools like Jenkins, Bamboo, and GitLab in the development space. Registry tools include things like JFrog Artifactory, Red Hat Quay, Amazon's Elastic Compute Services, Docker Registry, things like that. And then the runtime setup, I mentioned Creo, Containerd, Rocket, LXC. There are a ton of different runtime capabilities that help you manage containers. That's not an exhaustive list by any stretch of the imagination. The last time I looked, there were some 30 or 40 different tools just available in the commercial space. And that doesn't even include things such as open source technologies. So let me enhance this picture just a little bit. At the top, I'm sort of showing you once again the difference between development activities and production activities. But along the bottom, I've sort of feathered in here this concept of DevOps or DevSecOps. That's really the process associated with moving software from the CI/CD pipeline into the registry and ultimately into runtime. And it happens in a circular fashion. Orchestration, again, some of these tools like Azure Kubernetes Service, Apache Meso, Docker Swarm, all of those tools have the ability to reach deeply into the registry to pull images out to get them ready for deployment. And they talk to the master node to ensure that resources are spread out properly here. And so what I want to say to you here is that all of these 4 pipeline phases introduce an opportunity to scan for and identify security vulnerabilities. And there are tools that fit into each of those puzzle pieces. So when you think about vulnerability scanning within that pipeline, it's important to understand, well, what tools and systems does our organization use today? A very important component of that is what CI and CD tools are you using now? What system do you have in use as a registry today? Do we have the capacity for a staging registry? I'll come back to that topic in a minute, but a staging registry is essentially a copy of the traditional registry system that allows you to separate kind of a pre-production workspace for creating and posting images compared to like a final production ready registry that has the completed and supposedly secured images that you have built. And knowing all of that is critical to figure out what vulnerability scanning tool you need and will work in your environment. Many organizations put a premium on open source technology and they want to ensure that they're using an open source software product. But then again, there are a lot of powerful commercial tools out there as well. Budget obviously is going to come into play associated with that. And it's critical to know, well, at what phase of this container development pipeline do I really want to focus my security efforts on? That's going to have an impact on the tool and the methodology and the strategy that you ultimately select. I like to tell organizations to think about shifting left. That's not a term I made up, but what that means is kind of moving your security efforts further to the left of the model that I shared, meaning if you can get as close as humanly possible to the development and coding aspect of your process, the better off you're going to be. If you wait until you have code in production to do vulnerability scanning and to try to apply security fundamentals, ultimately that's going to cost you more and take more time and effort to fix those items. If you can nip it in the bud, perhaps at the beginning of your development process, you have a much better opportunity to make corrections more cheaply and more rapidly, which will benefit your organization. So now let's talk a little bit about the different vulnerability scanning strategies that you might want to consider. Really, the first thing that is important to talk about related to vulnerability scanning strategies is reducing your attack surface. Well, what does that mean? Well, your attack surface is simply the set of points on the boundary between all of these interconnected software components. And they represent points during which an attacker might be able to probe and prod and find a weakness and exploit your application or access your data or cause unanticipated consequences. And so it's really crucial to remember that you're responsible for everything you deploy out into the cloud. And so you want to try to minimize your attack surface, which means making your container images as small as possible, using the minimum number of management tools and software libraries and resources that you possibly can to ensure that the number of problem areas is minimized. So the idea here is if you can put out single purpose containers, if you can get rid of some of the default binaries and packages that come with your software, that libraries that you're using, that's better for you. You may want to take advantage of distroless images. It's very common today in the container development space to use what's called a distroless image, which is essentially a stripped down operating system that doesn't have any of the typical management tools and components that you might expect on a full-blown operating system. Many times that means actually removing things like a user shell or a package manager. And I'm going to touch on why that might not be a great idea in just a few minutes. But the idea here in terms of reducing the attack surface is making containers as small as they possibly can be, which will result in fewer vulnerabilities, and ultimately you'll have a smaller attack surface, and that's a good thing. I love the MITRE ATT&CK framework. If you're not familiar with that, on my slide here at the bottom, I've got a link that will take you to a live version of the MITRE ATT&CK matrix for containers. MITRE ATT&CK is simply a common vocabulary that is used to describe and explain different techniques, tactics, and procedures that malicious actors will use in terms of attacking different infrastructure components. MITRE started with this a few years ago by putting together TTPs for common operating systems, and they've quickly evolved into more specialized areas. And I love this containers matrix because it can highlight for you as a security professional where are the likely points of attack for a containerized development environment. This can help you kind of plan for the minimization of different security vulnerabilities conceptually so that you can pivot into using tools to help you identify some of these weak spots. Again, check out the link at the bottom here. It's really great information. If you've not visited the MITRE ATT&CK website, the cool thing is that this little matrix is kind of like a live action thing. So you can click on different concepts related to execution or persistence or credential access, and that will explode into a different view that gives you a lot more information about what you're reading. So what are the, hey Scott, what are the vulnerability scanning strategies that I need to understand? Well, there are a couple of different ways that you can go about doing this. The first strategy is to scan software within the development or build time cycle. And so, as I mentioned before, shifting left or pushing as close to your actual development work as possible is your best option in terms of identifying security vulnerabilities early. So move towards the CI/CD pipeline as best you can. The idea here is to scan your software for vulnerabilities and ensure that you're only putting clean software into your registry. That's an important step. You don't want to deploy junk to be out in production. The bad news about this particular scanning strategy is that it interrupts the workflow. So think about that for a minute. You've got your software coders, they're putting together software, they're building, they're committing, they're taking steps to get their code ready for deployment. You're going to call a timeout on that and say, well, hold on a minute. I want to scan your software for vulnerabilities. Let's make sure it's clean. And oh, by the way, wait for me to generate that report and I may be getting back to you with some things you need to fix. Not bad, but it's going to interrupt the workflow. And so there is a cost associated with that in terms of your development lifecycle and the time it takes to get code ready for deployment. The second scenario, though, is absolutely by a long shot the most popular strategy that I'll share with you, and that is scanning in the registry. So if you remember what I said about container registries, these are basically holding systems, holding cells for your finished container images as they are ready to be pushed out into deployment. So your orchestration engine will talk to the registry and say, hey, I need a copy of a web server. Okay, give me that container image and I'll make copies of it and roll it out. So your registry is really a great opportunity to scan for vulnerabilities for a couple of reasons. You can do those scans kind of any time. So it's an asynchronous capability, which doesn't interrupt your development shop. It allows you to kind of scan as often and as frequently as you want to. And you can rescan images as new vulnerabilities are identified and introduced, which is great. Because this is such a popular strategy, you're going to see in a few minutes that it has the best tool coverage. So almost every container scanning tool that I'll share with you today has the ability to integrate with the systems registry. And it's because it's such a valid place to do that work. I mentioned a bit ago about staging registries. This is something that we're starting to see much more common out in the real world. And so the idea here is that you take your registry system and you basically have a copy of it. So there's a staging registry and a production registry. And the idea here is you want to put all of your candidates for container images into the staging registry, scan the heck out of them like crazy in a repeat fashion. And then only once you are confirmed to have a good image, you feel comfortable that you've eliminated all of the security vulnerabilities, then you can copy that container image into your production registry. And from that production registry, either manually or through orchestration, you're ready to deploy that out into the production world. And this gives you a distinct capability to kind of separate some of the security and management functionality from the deploy and operate capability that I described before. So we're seeing it become more and more popular. As you might expect, larger organizations are adopting that model first, but I predict that it's going to become much more pervasive as the years go on. The third scanning strategy I'll talk about is runtime scanning, which is something you can probably anticipate very clearly what that is. So that just means scanning your running containers. And there are a lot of tools available to do that. One advantage of scanning your runtime environment is it actually gives you the best visibility into, hey, what vulnerabilities do I have right now that I need to care about? What is in my production environment that could represent a risk? It's also a good strategy to employ if you're concerned about container drift or rogue copies of containers. You know, one of the principles of containers is that they are immutable, meaning that they're unchanging images. But as I described for you several minutes ago, almost every container in use these days has kind of a writable layer, if for no other reason, to serve as a scratch area for things like logs and temp files and stuff. So they're not really 100% unchanging. And as a result of that, we've seen some organizations at IBM patch running containers or try to update packages on running containers. And what happens there is you start to get different copies of the same container, but they're not all the same. And that introduces a level of risk. So by scanning your containers in the runtime environment, you're getting the best view into, well, what vulnerabilities are here right now that I need to be concerned about. A challenge associated with this strategy is that each organization has to figure out, well, what exactly is my threshold? When do I need to act and when do I need to not act? For example, you might say to yourself, well, where we're going to draw the line is we want to make sure we have no critical and high vulnerabilities. And that might be good enough. Some organizations, specifically if they are under heavy compliance regulation or if they're a government entity, they may say, hey, you know what? No vulnerabilities are acceptable to us. We need to make sure that we can't identify any weaknesses in these containers. So in terms of prosecuting vulnerabilities, your group, your company, your org has to decide, well, where are we going to draw that line? And then finally, an advanced strategy is to use something like Kubernetes admission controllers. Admission controllers are a topic that I'm hoping to do a lot more research on in the future. But Kubernetes basically provides a very powerful API-driven interface to your container space that lets you apply certain decisions and logic to what's happening with your containers. And what I mean by that is you can write a Kubernetes admission controller that says, if I detect a running container that has X number of vulnerabilities, we'll pull that out of circulation or destroy it. You might also configure your admission controller to say, hey, I'm only going to pull an image from the production registry once I can validate that there is an acceptable vulnerability scan that has been completed. And that gives you some powerful tools to kind of automate some of the security with respect to deploying your containers. That's a really powerful thing to have in your toolkit. It can be sort of complex. Some of the larger organizations and dev shops in the container space already use admission controllers for other criteria, but we haven't seen a lot of activity related to admission controller technology specifically for security. Again, I think that's something that is absolutely going to change over time. So let's go back to the registry for a minute. I mentioned this before, but the registry segment of this process is where 99% of folks doing vulnerability scanning are operating. If you've got a tool like JFrog Artifactory, Red Hat Quay, or Docker Registry 2, all of the tools that we see out there common in the marketplace can talk to those registry systems. And what that means is they can actually intersect with the registry. They can scan images that have been published there and give you a report back on, hey, what vulnerabilities do I need to be concerned about? And typically you can get that in the form of some kind of a live dashboard. My screenshot here is showing a view into Qualys's container security tool. And so you can look at all the different registries and the images within there and produce many different reports showing, hey, where do we have the highest number of vulnerabilities and what are their severity levels and what things do we need to take action on? So it's a really powerful capability. Again, as I said, a lot of organizations are doing this whole staging versus production registry. And I highly recommend that you adopt that model if your organization can do so. One thing that's kind of interesting to me about containers is, when the container technology was first becoming popular, there was this assumption that containers only existed for a matter of minutes or hours, that they were always coming and going and becoming destroyed and repopulated based on supply and demand and actions in the cloud. And that isn't really as true as I initially thought that it was. In fact, a 2019 study from Sysdig showed that half of containers out in the production environment are only updated, weekly or less, which means that there is a continued opportunity for vulnerabilities to be introduced. If you've ever done anything with vulnerability management, you'll know that new weaponized attacks, proofs of concept, and vulnerability exploits are published every single day, in some cases thousands of times per day. And so if you think about it, a week is a pretty long time on the internet, and there are many opportunities for new vulnerabilities to be introduced and therefore resident in your running container space without your knowledge. And that's why it's really crucial to understand where are the opportunities that I can look for these vulnerabilities, detect what they are, and make a plan to get them fixed. So the idea in the grand scheme of things here is to scan throughout the container lifecycle. So you want to try to shift left to try to scan systems within your CI/CD build process so that you're catching vulnerabilities early before they get published into the registry. But you also want to scan images in your registry. Remember, these are candidates for deployment. So you want to make sure that the systems, that the software packages in your registry are as secure as they possibly can be. There's no reason to also not scan your running containers. Like I mentioned before, things like container drift, the population of rogue containers that you maybe didn't think about managing can all happen to you. And so it's critical to understand what vulnerabilities do I have in my running production environment at any moment in time. Definitely make use of Kubernetes admission controllers if you possibly can. There's a lot of great research out there that I'll point you to in a little bit that can tell you more about how to set up a container admission controller, Kubernetes admission controller, and how to properly manage that. And then last but not least, the final phase, continue scanning your hosts. Everything that I've said today about vulnerability scanning strategies for containers is important, but you can't ignore the host infrastructure as well. All of your cloud systems, your infrastructure components, they can have vulnerabilities as well. And so the traditional vulnerability management tools in the marketplace today can help you in that space, and you should continue to do that. So the message here is test early and test often. To the best of your ability, deploy these different strategies that I've outlined at every phase if you possibly can. Sometimes that's going to be cost prohibitive. And again, each organization needs to decide, what's our threshold? What does our budget look like? Some of the things I talked about before, what tools have we already invested in? And does that have an impact on what container scanning tools that we pick? There are a lot of great open source choices out there that might augment some investments you've already made. So let's get into some product comparison. And I want to make a few notes about that before we dive into the individual tools. These are really important things to consider. Not all of these products are equal. What I mean by that is they have different capabilities. So just to give you an example, Qualys, one of the tools that my team works quite a bit with, is actually delivered as a Docker image. So if you're not using Docker, well, guess what? Qualys is not going to be a great choice for you. The Tenable product, which is a really, really popular and powerful vulnerability scanning tool, can only scan registry images. Now, I suspect that's going to change because, in fact, Tenable's starting to make some acquisitions in this space to enhance their capability. But right now, they are only able to scan registry images. And so if scanning your running containers is a crucial aspect for your organization, well, then maybe Tenable might not be the best choice for that. A lot of different products that I'll share with you have open source equivalents, but also commercial flavors of those tools. And so what you will see is the tools that fall into that space maybe have some different capabilities for their commercial product compared with the open source system on which they are based. And remember that some of these products aren't necessarily compatible with all Linux containers. I've seen a couple of products that seem to be sort of like Azure or Google Cloud specific, but that's really not a huge consideration, but it's not a zero consideration. And then my second important note is some of these scanners, in fact, the majority of them, actually have trouble with distroless containers. Now, I just got done saying 20 minutes ago that you might want to consider a distroless container image as part of your build process. And again, what that means is you're talking about a container based on a super slim operating system that may have a lot of the traditional OS components removed. And the reason that that's a problem is many of the vulnerability scanner tools I'm going to share with you in just a second, they depend on things like the package manager to be able to enumerate the different versions of software libraries and code and stuff that is actually in your container image. And so if you take that out, all of a sudden you've lost a lot of capability. So keep that in mind as we look at what some of these products are and what they can do. So I've put together a matrix of some of the most popular vulnerability scanning products for containers. This is not a fully exhaustive list. I have to put together 10 slides to show every single product in the marketplace. These are the ones that I've researched as being the most popular, the most common, the most capable, and I've tried to identify which ones have an open source component versus a commercial component. So in my little chart here, if you see a red dot, that means yes, this tool can do that. So across the first line here, Anchor is a very popular tool. It can scan your CI/CD pipeline. What that means is you can actually integrate that with JFrog or with Jenkins to scan code before it gets published as a container image. It can scan the registry, but it can't scan running containers and it can't scan hosts. And so you'll see the varying capabilities of some of these tools. They're not all exactly the same. But as I mentioned before, you can see that I've put a red dot for every product under scans registry. All of these tools, Anchor, Trivy, Atomic CLI, Claire, they all can intersect with your registry and help you detect and identify vulnerabilities within that space. So that's good. The little circle that's like half gray, half red, what that means is there is a component that can do that capability, but it might either be the open source piece or it might be the commercial component. So that's a really critical consideration when you think about selecting some of these products. I am going to make this presentation available to everyone after. Of course, there's going to be a replay thanks to the CarolinaCon folks. So don't worry if you haven't been able to take a screen cap of this. I'll make it available to you later. Let's talk just briefly about compliance. Anytime you're talking about looking for vulnerabilities, it's important to consider, are there any compulsory things that I need to worry about from a security compliance viewpoint? And the answer is yes. Yes, there is. There are several different container-related compliance frameworks that are available today. Some of them are merely helpful in terms of advice and best practices. Some of them are absolutely required. I really like NIST Special Publication 800-190, which is titled Application Container Security. It's a great NIST document that can give you insight into how do I go about securing my container environment in my development shop. And it talks specifically about managing your container images. It specifically talks about scanning those images for malware and other things, but it definitely focuses on minimizing the attack surface, which we talked about a few minutes ago. One of the kind of interesting things about the NIST document is it gives equal weight to scanning systems in the registry and monitoring your runtime vulnerability load as well. And I thought that was kind of interesting. They're leaning towards the model that I put forward, which is to scan in every phase of that cycle if you can. Some of the other compliance frameworks like PCI and FedRAMP and even the GDPR for considerations for European data processing. They all talk about different requirements associated with specifically scanning containers. One of the things that I thought was really interesting is FedRAMP specifically talks about inventorying all of your containers, and scanning all of the registries on a monthly basis. Frankly, I would say you need to do it a heck of a lot more frequently than that. But just keep in mind that one of these compliance frameworks may very well apply to your organization, and it's important to be familiar with what they require. So in summary, a couple of conclusions for you. Containers, although they're supposed to be unchanging, actually are made up of multiple complex layers, and each of those layers can have potential vulnerabilities. And that's why it's critical to extend your vulnerability management program into the container space. Vulnerability management for containers really requires you to shift left, to push as close to your code development cycle as humanly possible so that you can fix vulnerabilities cheaply and more rapidly than you would do in a production environment. There are lots of opportunities, as I've described, for scanning sort of throughout the container pipeline. And that's important to find system weaknesses and eliminate them before you get bit in the fanny. The marketplace that I shared a minute ago has a pretty decent blend of both open source and commercial software tools that really can almost work in any environment. There's a lot of choices to be made on what tools right for your organization, but I hope I've armed you with enough information that you can begin that investigation. And then finally, compliance and demonstrable controls, that's never going out of style, right? We always live under the framework or the umbrella of security compliance, and the container space is no different. So make sure that you understand what regulations, what requirements apply to your company or your organization. A couple of takeaways for you here. My advice, build minimal base images. If you can use a distroless image and still successfully scan that image for vulnerabilities, do that. Use trusted software sources. Be cognizant of the limitations of the choices that you're making. Second, maintain all of the tools, packages, and libraries that you put in images. Let me tell you, anything you put in a container image, that's your baby, and you have to take care of it. You got to feed it, change its diaper, make sure it grows up to a successful adult. One thing that's actually kind of new in terms of maintaining container images is this concept of software bills of material. So about a year ago, President Biden issued a presidential executive order that is requiring federal government organizations and entities to maintain a software bill of materials that is basically a listing of all the different components and their sources that's going into your software package. And this was something that came out of the SolarWinds breach a little more than a year ago. SolarWinds perhaps didn't have a complete understanding of where they were getting their different packages that they were compiling into their software products. And so as a result of that, it's becoming more and more important to focus on software bills of material. There's a tool from Anchor called Sift, and another tool that you may have heard of called Trivy that's made by Aqua Security, well, commercially supported by Aqua. And those tools now have the ability to index your container image and basically barf out a software bill of materials. And so that's a really important factor you may want to consider, especially if you're obligated to follow that presidential executive order. Third takeaway, make sure you carefully select a vulnerability scanning tool that matches what your organization is doing today. If you are specifically focused on open source software, you may not want to choose a commercial product, especially if you have sort of a tight budget. But if you've already invested in a commercial product for traditional infrastructure vulnerability scanning, it might make sense to use that same company's product for container management. Make sure that you're planning to implement vulnerability scanning at every phase of the software development lifecycle or the CI/CD pipeline. All of those points along the process introduced opportunities for vulnerabilities to be attacked, and it's crucial that you apply as much oversight to those points as humanly possible. And then finally, consider some additional controls. I talked a little bit about staging registries. I mentioned Kubernetes admission controllers. We're starting to see more and more capabilities added to development shops that give them a better mechanism for control of their containers and for detecting security vulnerabilities. So keep an eye on this space. Make sure you're staying up to date with what these tools can bring to your team. That's all I have for you today, friends. In terms of references, as I put this presentation together, I came across dozens of really great resources. And so I have published this presentation to my GitHub repo, and in that same repo, you will find a bibliography document that has, like I said, dozens of links that'll give you a ton more information. So if you're interested in this topic, if you want to read more about it, definitely check out my bibliography to get some more information. Thank you so much. I again, really am appreciative of the 49th Security Division and the CarolinaCon organizers. Thanks a ton for having me today. Thank you.
Thank you, Scott. We will be taking.
If you're still listening, I am in the Discord channel. Hit me up if you have any questions.
Thank you, Scott. We will now be taking a short break with talks resuming at 1 p.m. Please join us then for Tales from To Usenet by Jason Evans.
Recording stopped.
You see me, I will burn the sense. Oh yes, bring it on by the weight of the key. You see me, I will burn the sense. Oh yes, your paper start the big split to me just pick up the wrist now, pull it with herb and burn it tight and when all the herbalists and ganja gog on them. Hang on, me, I will burn the sense. Oh yes, bring it on by the weight of the key. You see me, I will burn the sense. Oh yes, your paper start the big split to me just pick up the wrist now, pull it with herb and burn it tight and burn the sense. Me, I will burn the sense. Oh yes, bring it on by the weight of the key. You see me, I will burn the sense. Oh yes, your paper start the big split to me just pick up the wrist now, pull it with herb and burn it tight and me say here comes the cat original ganja man with the lyrics now among mic in my hand, vibes and all it does it like a vibration. Every massive man put him up and come China long. You see me, I will burn the sense. Oh yes, bring it on by the weight of the key. You see me, I will burn the sense. Oh yes, your paper start the big split to me just pick up the wrist now, pull it with herb and burn it tight and when all the herbalists and ganja gog see me, I will burn the sense. Oh yes, bring it, come by the weight of the key. You see me, I will burn the sense. Oh yes, your paper start the big spliff to me just pick up the wrist now, pull it with herb and burn it tight and burn the sense. Me say here comes the get original ganja man with the lyrics now my mouth, mic in my hand, vibes and all it does it like a vibration. Every massive man put him up, he come China long. You see me, I will burn the sense. Oh yes, bring it, come by the weight of the key. You see me, I will burn the sense. Oh yes, your paper start the big spliff to me just pick up the wrist now, pull it with herb and burn it tight and hang on. And ganja gag and them on the sense.
Master weapon.
Special request to our diarty dog out where they come from southwest, east or north. This is the roughest corner coming to take back no talk. Hear this, watch out. We are the roughest connect from out of South Park. Any boy test we have to draw a gun for. We are the roughest connect from out of South Park. Any boy test we have to draw a gun for. We are gonna dust out your blood. We are gonna shut out your blood. We are gonna dust out your blood. We are gonna shut out your blood. Watch out. We are gonna dust out your blood. We are gonna dust out your blood. We are gonna dust out your blood. Shut out, we are the roughest. We are gonna dust out your blood. We are gonna dust out your blood. We are gonna dust out your blood. We are gonna shut out, we are the roughest. We are the roughest. We are the roughest connect from out of South Park. Any boy test we have to draw a gun for. We are the roughest connect from out of South Park. Any boy test we have to draw a gun fast. Poison down, choke your right, get your heart on. The ragamuffin we not scared, not laughed on. We face bend, cause we not beg no friend. Test a dog got the bug up and we mark 10. We are the roughest. We are the roughest connect from out of South Park. Any boy test we have to draw a gun for. We are the roughest connect from where you the roughest.
Well, all ganja smoker, them I want you big up yourself, you know. Got a roughneck top cat coming back at you. And from a distance, can smell them upon the cali weed, man. Hear this. Me is a man, love me says. Me is a man, love me says. Jungle. Says where you want to them, we run that. The amount of says where you can't run out. That's not with them. Says where you want to them, we run that. The amount of says where you can't run out. That's not. Says where you want to them, we run that. The amount of says where you can't run out. That's not with them. Says where you want to them, we run that. The amount of says where you can't run out. That's not.
Say
can't run out. That's the way tell them. Just where you want tell them. When run that the amount of stress where you can't run out. That's the way tell them. Just where you want tell them. When run that the amount of stress where you can't run out. That's the way tell them. Just where you want tell them. When run that the amount of stress where you can't run out. That's the way tell them. Just where you want tell them. When run that the amount of stress where you can't run out. That's the way tell them. Me is a man, love me says. Me is a man, love me says. Me is a man, love me says. Special request to all the girls from north, south, east and west. From your body look good and you know you have the God bless. Broke wine, broke a man's spine. What you right now? Request this time. Big up on our chest. Request this time. Fake y'all and the girl. Big up on our chest. Whoa, watch out. Big up, bag up, big up, bag up, big up, big up, big up. So, oh man, you forget up and go and rock. Wind up your bumper, wind up and back. Find on your mate, cause she a dead stop. You and your massive run the place hot. Diane and Susie, Marcia and Pat. All of them a come a butterfly on the spot. See with your muggle, you know you look trash. Take it from the girl, listen, call it down. Get a what me tell them, me say. Request this time. Say y'all a dig y'all. Big up on our chest. Bag up on your
Well, all security force, I don't want to take it as no disrespect, but as a sense meal a smoker, may I have to tell them this. This a urban, herb a ganja. Security force, I'm talking to you, Mr. Bouncer. This a urban, herb a ganja. Security force, I'm talking to you, Mr. Bouncer. This a urban, herb a ganja. Security force, I'm talking to you, Mr. Bouncer. This a urban, herb a ganja. Security force, I'm talking to you, Mr. Bouncer. But tell the bouncer boy that me nah let me spliff. Me tell him nah let me spliff. Nah let me spliff. But tell the bouncer boy that me nah let me spliff. Me nah go put it on me socks about me, I go hide it. Or shove it down me brief about me, I go balls it. Me nah skin teeth with it in me pocket. Me I go walk to the gate with a big ganja spliff. Man, nah let me spliff. Nah let me spliff. But tell the bouncer boy that me nah let me spliff. Me tell him nah let me spliff. Nah let me spliff. But tell the bouncer boy that me nah let me spliff. Well, all security force. Well, all security force. But tell the bouncer boy that me nah let me spliff. Me is a youth man, well love me sense it. And all me smoke that are the green it. But tell the bouncer boy that me nah let me split. But tell the bouncer boy that me nah let me split. Nah let me split. Nah let me split. But tell the bouncer boy that me nah let me split. Me tell him nah let me split. Nah let me split. But tell the bouncer boy that me nah let me split. Me nah go put it on me socks about me, I go hide it. Or shove it down me brief about me, I go balls it. Me nah skin teeth with it in me pocket. Me I go walk to the gate with a big ganja split. Big ganja split. Well, all security force. I don't want to take it as no disrespect, but as a sense meal a smoker, may I have to tell them this. Me is a youth man, well love me sense it. Me is a youth man, well love me sense it. And all me smoke that are the green it.
One day some of the kids from the neighborhood carried my mother's groceries all the way home. You know why? It was out of respect.
No near man, the original nutter. Take in and take check. You can't patch along the shy effects. And when we come is murderation. All original gangster man. Here when we tell them no, you hear me coming to imitate. Originate, we come to originate. Alright, mate. Now what you doing, mate? Here when we tell them we come to from gears and I'm gonna stop talk. Watch me tell them, rude boy. Watch this. Nanini wo, zing na 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 no no no. Nanini wo, zing na 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 no no no. Nanini wo, zing na na na.
watch out. You never know the gangster, me say them in a jungle. Well, you never know the article, me say them in a jungle. Well, you never know shy effects, man, big in a jungle. Well, you never know you Kapache, big in a jungle. When we tell everybody, watch it now, man. Me a the nutter, original man, nutter, original man, nutter, original man, nutter, original me a the nutter, me better than the bad boy, 'cause they da fear. Lock off the jet where you call Skywalker. In a one school, them call me troublemaker. Better than the predator and the dominator. Better than the garden and the dandada. So who try your thing, you ain't quite butter. Until you try your flex man, not control the border. Dibby, we tell you what, me ball. Down in the world, sing a na na no no no. Down in the world, sing a na na no no no. Down in the world, sing a na na no 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 no. No 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 no. Bad boys in a London, rude boys in a England, bad boys in a Jamaica, rude boys in a Kingston. Watch out, you never know the gangster, me say them in a jungle. Well, you never know the article, me say them in a jungle. Well, you never know shy effects, man, big in a jungle. Well, you never know you Kapache rule the jungle. Well, me a the nutter, original man, nutter, original man, nutter, original man, nutter, original man, me a the nutter, me better than the bad boy, 'cause they da fear. Lock off the jet where you call Skywalker. In a one school, them call me troublemaker. Better than the predator and the dominator. Better than the garden and the dandada. Until you can't patch him and I can't show the border. Yes, I am fix man, pull up on no lighter. We will tell the people, even a rude boy man, I am a murderer. Kill up any DJ on the corner. You hear me? Shy fix him is a murderer. I kill up any DJ on the corner. We will tell the even a rude boy man.
One day some of the kids from the neighborhood carried my mother's groceries all the way home. You know why? It was out of respect.
No name man, the original nutter. Take in and take check. You can't patch along the shy effects. And when we come is murderation. All original gangster man. Here when we tell them no, you hear me coming to imitate, originate, we come to originate. Alright mate, now what you doing mate? Here when we tell them we come to the gears, man, I'm gonna stop that. Watch me tell them rude boy. Watch this. Down in the world, sing a na na no no no. Down in the world, sing a na na no no no. Down in the world, sing a na na no no no. No 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 no. Bad boys in a London, rude boys in a England, bad boys in a Jamaica, rude boys in a Kingston. Watch out, you never know the gangster, me say them in a jungle. You never know the article, me say them in a jungle. Well, you never know shy effects, man, big in a jungle. Well, you never know you Kapache, big in a jungle. When we tell everybody, watch it now, man. Me a the nutter, original man, nutter, original man, nutter, original man, nutter, original man, me a the nutter, me better than the bad boy, 'cause they da fear. Lock off the jet where you call Skywalker. In a one school, them call me troublemaker. Better than the predator and the dominator. Better than the garden and the dandada. So who try your thing, you ain't quite butter. Until you try your flex man, not control the border. Dibby, we tell you what, me ball. Down in the world, sing a na na no no no. Down in the world, sing a na na no no no. Down in the world, sing a na na no no no. No 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 no. Bad boys in a London, rude boys in a England, bad boys in a Jamaica, rude boys in a Kingston. Watch out, you never know the gangster, me say them in a jungle. Well, a the nutter, original man, nutter, original man, nutter, original man, nutter, original man, me a the nutter, me better than the bad boy, 'cause they da beard, like a the way you call Skywalker. In a one school, them call me troublemaker, better than the predator and the dominator, better than the gargan and the dandada. I tell you, you can't patch him and I got you the border. Yes, I am vex man, pull up on no lighter. What we tell the people, even a rude boy man, I am a murderer, kill up any DJ on the corner. You hear me? Shy vex him is a murderer, I kill up any DJ on the corner. What we tell the even a rude boy man.
One day some of the kids from the neighborhood carried my mother's groceries all the way home. You know why? It was out of respect.
No name man, the original nutter. Take in and take check. You can't patch along the shy effects. And when we come is murderation, all original gangster man. Here when we tell them now, you hear me coming to imitate, originate, we come to originate. Alright mate, now what you doing mate? Here when we tell them we come to the gears, man, I'm gonna stop that. Watch me tell them rude boy. Watch this. Bad boys in a London, rude boys in a England, bad boys in a Jamaica, rude boys in a Kingston. Watch out, you never know the gangster, me say them in a jungle. Well, you never know the article, me say them in a jungle. Well, you never know shy effects, man, big in a jungle. Well, you never know you can patch it, big in a jungle. When we tell everybody, watch it now, man. Me a the nutter, original man, nutter, original man, nutter, original man, nutter, original man. Me a the nutter, me better than the bad boy, 'cause they da beard. Like a the way you call Skywalker. In a one school, them call me troublemaker. Better than the predator and the dominator. Better than the gargan and the dandada. So who try a thing, you ain't quite butter. Until you try a vex man, not control the border. Divi, we tell you why, me ball. Down in the world, singing like na na no no no. Down in the world, singing like na na no no no. Down in the world, singing like na na no no no. No 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 no. Bad boys in a London, rude boys in a England, bad boys in a Jamaica, rude boys in a Kingston. Watch out, you never know the gangster, me say them in a jungle. Well, you never know the article, me say them in a jungle. Well, me a the nutter, original man nutter, original man nutter, original man nutter, original man. Me a the nutter, me better than the bad boy 'cause they da beard. Like half the dead when you call Skywalker. In a one school them call me troublemaker. Better than the predator and the dominator. Better than the gargoyle and the dandada. I tell you can't patch him and I can't do the border. Yes, I am vex man, pull up on no lighter. We tell the people, even a rude boy man, I am a murderer. Kill up any DJ on the corner. You hear me? Shy vex him is a murderer. I kill up any DJ on the corner. We tell the even a rude boy man.
A special request. 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 Well, hold on, 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 a special request.
are dealing with rude boy.
Life, love, peace with equality.
So that's all.
No, excess amount of badness if necessary. Excess amount of badness is necessary. than the rest, rougher than the rest. All of the girls them a show me say me rougher than the rest, rougher than the rest, rougher than the rest. All of the girls them a show me say me rougher than the rest.
Come and dance, come on, come shack out, so me say, jump on your saddle, ride up on your back. Walk, come and dance, come on, come shack out, so me say, jump on your saddle, ride up on your back. Jump on your saddle, ride up on your back. Jump on your saddle, ride up on your back. Jump on your saddle, ride up on your back. Jump on your saddle, ride up on your back. Walk, come and dance, come on, come shack out, so me say, jump on your saddle, ride up on your back. Jump on your saddle, ride up on your back. Jump on your
be some kind of superhero.
Yo, you have a license to play this? Oh, my operator don't have a license, man. If you get a license to play them kind of dope plate here, you know. You see, want to get locked up. Sure. I tell you, you're dangerous enough. Yo, you have a license to play this? Yo, you have a license to play this? Dangerous enough, so. Discharge them kind of dub upon people innocent ears. Circle.
Welcome back from lunch, everyone. Up next, we have Tales from the Usenet by Jason Evans. Jason is going to be talking about some of the wonderful world of Usenet, the communication platform that predates the internet. Settle in as Jason talks about the history of Usenet and gives you some anecdotes from the past. He will be in the Discord, in the voice chat, and in the speaker chat.
Tales from the Usenet, CarolinaCon 2. Tales from the Usenet, CarolinaCon 2. Testing 1, 2, 3. Tales from the Usenet at CarolinaCon Online 2. Tales from the Usenet, CarolinaCon 2. Testing 1, 2, 3. Tales from the Usenet at CarolinaCon Online 2. Let's start with a little about me. My name is Jason Evans. I am a training engineer for SUSE Linux. I am also a board member for the Usenet Big 8 Management Board. We'll talk a little bit about what that means in just a moment. I'm a volunteer for the Tor project. I do tech support and like new user help on forums like Reddit and Stack Exchange. I'm not an official part of Tor project, but I do volunteer. I attend meetings sometimes. I do like the project and what they're doing, so I try to be a part of that. And I'm an all-around nerd. I've got a lot of different weird nerdy interests. I used to live in the Triangle. I lived in the Triangle for 15 years, from 2000 to 2015. And then I got the chance to move to Europe, where I am now in Prague, Czech Republic. So let's begin with what is Usenet. The simplest definition I could find was Usenet is a decentralized, worldwide, peer-to-peer system for circulating newsgroup articles. On Usenet, we call messages articles. Get it? News articles. It has grown somewhat chaotically from the very small beginnings, mostly as a labor of love. Most people who use Usenet now do it because they want to. There aren't that many people who get paid for Usenet use or anything. There are some companies out there that still provide Usenet service, but for the most part, people who use it are there because they want to use it. It is the original long-form messaging system that predates the internet as we know it. Now, back in 1979, whenever they first set up the first Usenet devices, there was no internet. There was the ARPANET, which was a U.S. government program, but there was no internet. Now we come to the more interesting definition of Usenet. Usenet is like a herd of performing elephants with diarrhea. Massive, difficult to redirect, all-inspiring, entertaining, and a source of mind-boggling amounts of excrement when you least expect it. And that's from Gene Spafford back in 1992. 1992 time frame is what I would consider to be probably the golden age of Usenet, and that's something that we're going to talk about today. So how does it work? Users read and send articles, that is messages, on a news server. That server exchanges articles with other news servers across the Usenet, across the network. The collection of servers is known as the Usenet. So there is no top-down structure to Usenet whatsoever. Everything is peer-to-peer. It's all peer-to-peer messaging. So let's begin with a little bit of history. In 1980, there was no internet. There was only the ARPANET, and few had access. From the stories that I've read, at the time, most universities and research institutions didn't even have ARPANET access. You needed to have political connections as well as a substantial amount of money to even get those connections. Two of the schools that did not have access to the ARPANET would be Duke and UNC. Email has been around, so we needed something that was better than email. Email's been around since before the Usenet. At the time, you could send messages to another person on the same machine, especially if you're using a mainframe or if you're using a mini computer where different people had different dumb terminals. You could send messages to each other. That would be email. But there was no way to really send that to another person on another machine or to another city. There were a few people had modems. Even like the first Usenet modems had been cobbled together by as projects. There was really no way to talk to people outside with the ARPANET. So if you had somebody on the ARPANET and they want to talk to somebody who wasn't on the ARPANET, they literally would have to call them or send them snail mail, because there's no interconnectivity between the systems. And I'm sure somebody had hacked together something once or twice. I'm sure there had been a few things where that happened, but by and large that wasn't not common. So let's begin with Duke and UNC. In 1979, students from Duke and UNC had PDP-11 mini computers. The picture on the left is from Duke. The picture on the right is from UNC. And at about that time, the new Unix version 7 came out, and that included a command called UUCP, or Unix to Unix copy. Now, this had originally been meant to just send one-off messages from user to user, or from machine to machine, and that could go by modem. But they wanted to have a way to actually have multiple messages going out to people. There had been things like mailing lists before, where you can send mail to a mailing list and other people on the machine could get that, and you can have different discussion topics. But to be able to actually go from computer to computer and actually have places where you can just go check your messages and have multiple machines that would talk to each other, not just one or two, but actually 3, 4, dozen, 100 different computers talk to each other. That was something that was different. And this is actually before the first BBSs. The first BBSs came out in the early 80s. This was actually started as a project in November 1979. So let's talk about the rise and the fall of Usenet. So this is the beginning. In the beginning, the Usenet achieved rapid growth. Hundreds of new servers were added yearly. Universities and other institutions wanted to be a part of this network because they knew that knowledge and communication is everything when it comes to growth. So what had happened is in 1980, the students from Duke had been at the Usenix conference and had presented this Usenet project that they were working on. And it grew like wildfire after that. You can see by the end of 1980, there were 15 different universities and research institutions that were on this. And that just exploded from there. So here's a logical map of what Usenet looked like in 1981. We can see here there's a few machines from Duke, a few machines from UNC. There were machines from Cornell, from Toronto. Microsoft is actually on here. They had their own PDP-11 or some similar VAX mini computer that was on here. Purdue University is on here. And they were part of this connection where they were able to send messages to each other. Now, because this is probably on 300 baud modems, and telephone expenses, long distance calling was really expensive at the time. You had a few groups like Microsoft that had deep pockets that would do more calling than others. So the smaller institutions probably couldn't afford $1,000 or $2,000 a month on telephone bills. So some of the bigger ones would pick up and actually call them instead of them calling out. And this worked. This worked for a while. And as you can see, it really blew up, especially whenever hardline connections started becoming more common, and whenever the internet itself started coming in, where people actually had a static connection to an internet without needing to dial to a bunch of other users at the same time. So let's look at that. So this is a map of the Usenet in 1993. So this is 13 years later, and all of the black dots are connections and the of servers on the Usenet. We've got, of course, the United States is completely covered, so is most of Western Europe, but we also have several in Australia, Japan, South America, and because this is 1993 and after the after the fall of the Soviet Union, we actually do have connections here from Russia, from Poland, and several of the Eastern Bloc countries. So what would happen? How did an actual user start using Usenet? Well, during the golden age and during the early 90s, before people had like home internet access, most users were from, again, research institutions, universities, and corporations. Every September, new freshmen would arrive in the computer science programs and other STEM programs, and they would be given their access to Usenet, but they would also be enculturated into how to use Usenet. You know, how do you not make a fool of yourself? How do you get along with other people on this Usenet thing? And then in 1993, America Online offered Usenet. Now, there had been other commercial entities offering Usenet prior to this, but they were more difficult to use. They were really focused at the computer savvy users, but AOL was a general purpose platform for everybody. If you're as old as I am, you probably remember getting floppy disks and CD-ROMs in the mail for AOL during the 90s. With AOL's focus on being easy to use and for everybody, this enculturation was gone. There was now nobody there to tell people how to use Usenet, how to be a part of the community. And it went kind of crazy. At first, it wasn't that big of a deal. I've actually read some of those old archives during this time. Most of the things where people were just using bad grammar, bad practice on Usenet, for example, typing in all caps or starting flame wars and things like that. That was pretty easy to handle because you would say, okay, hey, so-and-so, this isn't how we do things here. If you want us to work with you, you have to be in line with what the standards are for this community. And things weren't that bad, but this kind of opened the door for users to start using Usenet all the time without any kind of way to learn what it means to be on the Usenet. A few years later, the largest web-based Usenet service, which was Deja, was bought out by Google. Google then started up Google Groups, which provided Google's own forums in addition to Usenet. The problem is that even to this day, Google never put in any kind of spam blocking. So if you wanted to comment on YouTube, you need to log in and do all of the stuff. If you want to spam the entire Usenet, you just need an account. You don't actually. There's nothing there to keep you from spamming multiple groups with whatever crap that you want, and that's still going on today. Right now, Google is the largest spammer on Usenet. And then things started going downhill. This is from 2005. AOL pulls the plug on their newsgroup service, and this was not just AOL. This was actually a lot of companies that were doing the same thing. And the reason why is because there are two types of news groups. There are binary groups where you can get pictures and videos and software, and then there are talk groups. Well, what happened is that the binary groups started being used for child pornography. And a lot of the ISPs decided, you know what, we can't stop this Usenet thing. Trust me, they had tried. Usenet providers have been sued so many times at this point, but there's nothing you can do. Just because one server decides to pull articles, it's a completely peer-to-peer system. It still is. Just because there are these issues and somebody pulls articles from one server, it doesn't affect the rest of Usenet. The rest of Usenet can keep on going on without being affected by one server going down. So the ISPs decided to stop carrying Usenet. So you can see here, Verizon, Sprint, Time Warner, all decided to stop carrying Usenet about the same time. And this is about the same time that AOL started dropping their service. And because people couldn't get a free and easy way to get to Usenet, I think this more than anything has hurt Usenet. Now, there are still free services that you can go out there and you can just get an account and use Usenet. And there are lots of paid services where you can do the same thing. But it's not like this. It's not the same thing as having it just a part of your current service where you can just log in and use it. Sadly, a few years later, Duke took down their Usenet server. So one of the first computers to actually use Usenet was in Duke, and Duke had been running their own server for many years. And then, sadly, they shut down their server not long after that. This is about 2009. Mostly because people had decided to use Facebook, Reddit, and other forums. And there are good and bad reasons to do this. But the biggest problem is that people didn't want to deal with spam. But that's, that's a discussion that we can have. Is spam really that big of a deal? Well, it's the whole reality of Usenet being that it's peer-to-peer means that it's up to the user to block what they don't want to see. There are moderated groups out there, but there's not many. So for the most part, it's up to you to block what you don't want to see rather than expecting a moderator to do it for you. So why go on Usenet and have to block what I don't like whenever I can just go to Reddit and let somebody else do it for me until that person on Reddit decides they don't like you and they block you anyway. So there's no shadow banning on Usenet. There's no outright banning because somebody doesn't like you. All they can do is block you. And if they complain to your provider, then you just go to another provider or you change your name. On Usenet, it's kind of like the Wild West, but it also gave you the freedom to do what you want. This is the Usenet as of 2020. So it is significantly smaller than that picture we saw from 1993, but it is still going. And not all of these are corporate entities. A lot of these are people like you and I who run their own servers. They're hobbyists, they believe in Usenet, they want to see it thrive, and they keep their servers up, and that way we can keep the network going. You can't kill the Usenet unless you take down everything. And even then, there's nothing stopping two servers from making connections and starting a new Usenet. That's just the reality of the peer-to-peer nature of Usenet. So, how are we bringing things back from the dead? In 2014, all of the members of the Big 8 Management Board, these are the people who ran the Big 8 hierarchies in Usenet. These are the traditional hierarchies that have been there, not since the beginning, but they are the descendants from the groups from the beginning. All the members who ran this board stepped down or they let their membership lapse, and the board was basically dead. Without the Big 8 board, no new news groups in these hierarchies could be created, old ones could not be removed, and changes could not be made to existing groups, etc. And then I posted on Reddit in 2020 a open letter that I had sent to the board because the board email was still up. And I got a response. And actually, at the same time that I had posted this open letter, someone else had actually written to the board at the same time, just happenstance. And we actually got together, and we had a meeting with the former board members. And from that point on, my colleague Tristan Miller and I became the board members for Usenet Big 8 management board, and we also added in one more person, so now we're a board of 3. You just so we can make changes together and be able to have a functioning board. So that's what we're doing right now. So this is our website. We are currently up and running. We have weekly meetings. We've created we created our first new news group last fall. We've deleted a few old news groups this year, and we're looking forward to continuing to add new news groups, make positive changes, and also do outreach like we're doing right now to try to get people interested in using Usenet again. We've also got a subreddit, which is r/classic Usenet, and we are openly trying to educate people on what is Usenet and how we can get people to use it again. I think it's important that we have a moderation-free distributed chat network. By being moderation-free, well, it's not completely moderation-free, but it's not being centered around a specific company or organization. We are peer-to-peer, so what one peer does not necessarily affect the other peers. Now, as a rule, like if somebody creates a new news group, we try to get all of our peers to also carry it, but it's not necessary. I mean, it's not absolute that they will do it. But we have a pretty good track record of working together. If one peer decides to start spamming everybody else, we can cut them off. If one peer goes dead, they decided to take down their server, it doesn't hurt the rest of the network. So we think it's resilient, and we think it's really great when it comes to dealing with things like censorship. So this is the new group that we created last fall. It's comp.infosystems.gemini. Gemini is an awesome project that basically is a cross between Gopher and the web. It's completely secure, but also minimal in that you don't have to worry about things like cookies or other things that you find annoying on the web. So I'm not actually a part of this this project so much. I do use Gemini from time to time, but it was cool that we actually got to create a new news group with people who are interested in using Usenet. So let's talk about some of the stories from Usenet, and that's really what we're here for today. These are not in any specific order. I just want to talk about some of the stories from Usenet to kind of give you an idea of what it was like, but also some of the weirder things that happened during our time. We're going to start with probably one of the most famous stories from Usenet, and that is from a grad student in Finland. So in 1991, a Finnish grad student by the name of Linus Torvalds was interested in designing his own operating system. At the time, some hobbyists were using a closed-sourced OS that was based on Unix called Minix. Linus wanted his OS to be free, but he promised that it wouldn't be big and professional. And here's his article. So he writes, I'm doing a free operating system. It's just a hobby. It won't be big and professional like GNU. The GNU he's referring to is GNU Herd. And if you know anything about operating systems, it was never really very big for 386 and 486 clones. This has been brewing since April and is starting to get ready. I'd like any feedback on things people like or dislike about Minix, and my OS resembles it's somewhat same physical layout of the file system due to practical reasons and other things. So this is Linus's opening email discussing Linux. And of course, this became incredibly popular. This is the kind of things that you could expect to see on Usenet in 1991. You could see people talking about new ideas and new projects, while things were much more limited in that people were on dial-up modems. Maybe Linus being at the university probably didn't need to dial up, but a lot of people did. If you wanted to see the newest software packages, you would probably come to Usenet and find somebody who's talking about it. If you want to find out what's kind of happening with Unix, if you want to see what's happening with Windows, this would be the place to go. Of course, it didn't take long for disagreements to arise. Andrew Tenenbaum, the originator of Minix, the non-free Unix-like system for students, said that Linux is obsolete. But notice how he did it. While the article summary is somewhat inflammatory, saying that Linux is obsolete, he gave his reasons why calmly. These two threads persisted on Usenet for literally years. It was Usenet at its finest. In these years, the signal-to-noise ratio was fantastic. I would argue that, again, that the early 90s was the golden age for Usenet. That's not to say that there wasn't the occasional trolling, and there was a modicum of spam out there, but it was pretty tiny. But for the most part, the conversations were great, and people who used it respected each other. So this is one of the first funny instances of Usenet, and this is from the very early days. This is Kremvax. Starting in April 1st, 1984, there was an article sent out from the Soviet Union to Usenet to announce that they are officially on Usenet. And I'll leave this up here for just a moment so you can read it. But it's basically the Soviet Union saying, someone from the Soviet Union is saying, yes, we have our own server, and now we want to join Usenet. At the time, most Usenet servers were using, on Usenet were on dumb terminals at universities, and the servers were running PDP-11 or VAX or other types of mini computers. And at the time, it wasn't really known if it was possible to spoof a user or a complete server. Kremvax was proof that it was. So this was actually a really funny joke that they put out. Obviously, it's on April Fools. And there was a lot of spam, a lot of feedback. This was a huge flame war that went on because of this, because people were so upset that somebody was posting jokes on the Usenet. And again, this is 1984, so the Usenet had only been around for about 4 years, really. So yeah, this is great. This is an example of one of the responses, and I wanted to point out something here at the very end of this. In the 90s and in the early 2000s, parents and legislators were talking a lot about internet addiction. A whole 10 years before the Eternal September and years before the Internet of the Web, people were already talking about why people were taking the Usenet, being on the net, as he says it, so seriously. So I just like this thing. I know that's the case with some people. That's why the term nerd applies to computer people and not to those who spend all weekend watching TV sports. The real user is how well-rounded people's lives are. Flamers should go to dev/shrink, please. So I like this. I like the fact that it's sarcastic, but it's also kind of foreboding about how people would see their lives on the net years before there even was an internet. Let's talk about cypherpunks. Cypherpunks are one of my favorite groups on the old internet, and it's from them that we get a lot of our security that we have today. The Cypherpunks mailing list and then the alt.cypherpunks newsgroup was the home for a group of anti-authoritarian hackers who cared about online freedom and privacy. Both the newsgroup and the mailing list were home to individuals like the early cryptocurrency advocates. Online anarchists would be folks like the pre-WikiLeaks Julian Assange. As this news article states, the mailing list was originally started by John Gilmore, who is a founding member of the EFF, or the Electronic Freedom Foundation. Sadly, the newsgroup didn't quite have the punch that the mailing list had in its prime, but it was a step forward. So this is just a cool little story about how whenever the mailing list got shut down, the cypherpunks were able to go to Usenet and still be able to function as they had been. So one of the people who was famous on the cypherpunks mailing list and also on the Usenet newsgroup was Tim May. Tim May was one of the major visitors to the Cypherpunks mailing list and the news group. This was an example. This is an example of an article that was discussed that he wrote years before the anonymous Satoshi Nakamoto invented Bitcoin. Was Nakamoto a member of these communities? It's impossible to say, but these communities were certainly influential on people like him or her. Before we leave the cypherpunks, I wanted to point out one more brief mention, and that is Phil Zimmerman's posting of the source code for PGP, or Pretty Good Privacy, in 1991 on Usenet. Without PGP, we would not have the internet security that we know today. At the time, strong encryption wasn't meant to be in the hands of regular people, and it was regulated with the same kind of legal pressure as firearms. Zimmerman was soon investigated by the government, and the indictment against him only ended 5 years later. PGP wasn't hidden away in some scholarly article on theoretical encryption. It was in the hands of people who needed it and used it, available on the Usenet. So this was actually just the beginning message for that article, and it was the first of 5 articles, and together this was the source code for PGP. And because I don't want to have 20 different slides with source code, we only get the beginning here, but it's good to see where that came from. All right, let's talk about a few more. This is one, unfortunately, I couldn't find the original article on, so I just have to paste what I could find. You've probably heard of IMDb before. IMDb is Internet Movie Database. It's a very popular website. It was bought out by Amazon a few years ago. IMDb actually got it started as a set of Unix shell scripts. And they were written by Colin Needham, who is still the CEO of IMDb to this day. The scripts were distributed on the newsgroup rec.arts.movies. So, back in the day, if you wanted your own copy of IMDb, you could get it. He provided this free of charge on the Usenet. So this is just another thing. This is 1993. This is still that same early version of Usenet before a lot of people were before a lot of people were on the Usenet, or before a lot of people were on the internet, I should say. So it's really cool that this was something that was out there. Another thing that happened during this time was the alt.Scientology war. This is an article from Wired that, as I said earlier, lots of people had tried to sue different Usenet providers over the years, and one of them was the Church of Scientology. Now, I'm not going to talk here about Scientology specifically, but I will say that on the Usenet, someone had published many documents that had been copyrighted and owned by the Church of Scientology as a means to educate people about what it believes. And before this point, all of this had been like internal secrets to their church. And because of this, Scientology, this Church of Scientology went a little crazy with their lawsuits and against individuals and against different services. But what they eventually found out is that they couldn't really put a dent in this, because the Usenet being peer-to-peer, even if they were to sue, let's say, Verizon because they had their own news server or something and they were disseminating it, they would have to sue each and every news server, and that just wasn't going to happen. They eventually did get some of the larger services to delete those articles, but they couldn't get everybody to, and that's part of the resiliency of the Usenet. All right, well, thanks for coming to my talk. Again, my name is Jason Evans, and I will
Awesome talk, Jason. Our next talk is Cameras, CACs, and Clocks, Enterprise IoT Security Sucks by Brian Contos at 2 p.m.
Jungle fever, I said it's the hinty. Jungle fever, I said it's the hinty. Jungle fever, I said it's the hinty.
Hang on! This one a different kind of big up. This one the original big up. This one going out to all Imperial junglers. No Stevie I for time. Kenny Ken movie. Herald being tied to the maximum. No calling the mix of maximum respect over the years.
Every man do his thing a little way different. Every man do his thing a little way different. The things I do it in a different way from you. The things you do it in a different way from I. Every man do his thing a little way different. Every man do his thing a little way different. No matter what color, race or creed that he may be, you too bad mind. No, check it, girl.
All of me wanna, all of me like, all of me need it. All he says, that I the up that give me consciousness. All of me wanna, all of me like, all of me need it. All he says, that I the up that give me consciousness. All of me wanna, all of me like, all of me need it. All he says, that I the up that give me consciousness. All of me wanna, all of me like, all of me need it. All he says, that I the up that give me consciousness.
Hey Mark, just wanted to let you know the mic is hot, but you're free to share your screen whenever you're ready.
Jungle fever, I said it's the
Hey, Trevor.
hinty.
Just checking to see my setup works.
it is here. Yeah, the girls will never get enough man and you talking store, man. Original Mr. Pecos for the alley galley with them body no matter. You will tell me, son, no? Skin out. girls we never get enough on a new talking tour, man. Original Mr. Pecos for the all the galley with them body no matter. You ever tell me, son, no? Skin out!
Well, here it comes, drum and bass wise, and otherwise you got to realize it's strictly rhythm wise. Well, here it comes, drum and bass wise, and
Up next, we will have cameras, CACs, and clocks. Enterprise IoT security sucks. A story of 2 million interrogated devices by Brian Contos. Brian will be discussing with us the wonderful world of enterprise IoT security. What sort of threats lie within these devices and tactics that will be used to protect your network while still getting some of value from these devices. Brian, take it away.
Hey everybody, I'm Brian Contos. I'm the Chief Security Officer with Phosphorus Cybersecurity. Today's presentation is Cameras, Cacks, and Clocks, Enterprise IoT Security Sucks. This is a story of 2 million interrogated IoT devices. So let's just jump right in. A little bit about my background. I've been in cyber for about 25 years. I've worked all over the world, mostly pre-COVID. Prior to Phosphorus, I started my career with DISA, then later Bell Labs, and then just started building startup companies. ArcSight, Riptech, Imperva, Solera Networks, and a few others. I sit on a couple different boards. I've written some books. In fact, in 2007, I wrote a book with the former director of the NSA, Bill Kroll, which was focused particularly on physical and logical security convergence, which took IoT sort of into consideration a little bit before its day, however. But certainly some of the tenets of that research fall into what we're going to be talking about today. So before we start, a little bit of background on the research. So we started this in 2017, and it's actually still ongoing. And we've looked at millions and millions of production, customer, enterprise IoT devices. So this isn't in a lab environment. These are actually real enterprise IoT devices running in operation today. Most of these customers are what you'd consider Fortune 500, Global 2000, government agencies. And what we're focusing on again is enterprise IoT. It's not consumer IoT, which you might think of as a Ring doorbell, a Roomba vacuum cleaner, an Alexa, these types of cloud managed IoT devices. But the term IoT is very expansive. It can incorporate industrial IoT, OT devices like SCADA and weapon systems, battlefield of things as well, Industry 4.0, smart buildings, smart cities, and so many other things. For the sake of this presentation, we really just want to focus on those IoT devices that you commonly find in the enterprises. In addition to this, we're not going to be focusing on taking a device, ripping apart the hardware, pulling out an oscilloscope, looking at the chips, dissecting the firmware for vulnerabilities. That's valuable. There's a lot of great presentations on that, but this is really about enterprise operations of IoT devices. So what are we going to cover? I'm going to give you a very short, extremely short technical history with the IoT primer just to sort of frame things. And then we're really going to just jump into the stats, some really interesting war stories from the trenches, who some of the biggest offenders are in terms of IoT devices, and then to make things a little fun at the end, what we can learn from Star Wars in terms of how to deal with enterprise IoT security risk mitigation. So here's that short historical primer. I think this is a really great way to frame IoT. So if we think about innovations of civilization sort of from the dawn of history, if you will, we had cave paintings in 20,000 BC. But we tend to have these big leaps forward when things jump out, whether that's the alphabet or written language using paper, things of that nature. But I draw your attention to 1804 here with Joseph Marie Jacquard, and he invented the automatic loom. Now this is really interesting. Making blankets and rugs and textiles before this was all done completely manual. It was there was no automation involved. It was very laborious. And he invented this device, which was essentially the predecessor to the computer. It was a mechanical computer, but it had input, it had output, it had storage. And if you look at some of these pictures, you can see it looks like punched cards or, punch tape even, which was the predecessor to punched cards. And that's how it was processing this information. And essentially what happened was it allowed these manufacturers of these textiles to increase productivity sometimes over 1,000%. So they're pretty amazing. You could have multiple looms inside a factory. So arguably, this is the world's first computer, leveraging mechanical automation, but some level of automation to increase productivity. The backstory to this is actually pretty interesting because the employees they were nervous about this. They're like, look, we're going to lose our jobs to this computer. They didn't call it a computer, but we're going to lose our jobs to this thing. So they actually broke into the factories one night and they smashed them. They destroyed them. And I always thought it was very ironic that the world's first computer suffered an insider threat. And we see those insider threats as well on the IoT side. And then, of course, once we get over to, post ARPANET, like 1969, and we get over to 1973 when we start developing TCP/IP and Ethernet comes out, we start having these major leaps forward. The personal computer in 1980. But from an IoT side, the first sort of roots, the inkling, we didn't call it IoT then, it probably really shouldn't be considered IoT, was in 1982. A Coke machine was actually connected to ARPANET to tell folks how many cans were still in there. There's actually modern IoT versions that live in vending machines today that do exactly that thing, probably built a little bit better. Then we had web browsers. The first official IoT device, and this was actually before the term IoT came out, which wasn't even until I think 1999, but it was a TCP/IP toaster. That was the first official IoT device, and that was back in 1990. Then Linux comes out in 91. We've got cameras on the web, and of course security cameras now are one of the most common IoT devices we see in the enterprise, and also one of the most commonly exploited. There's lots of things you can do there. Google's founded in 98. And then LG in 99 announces the first internet-enabled refrigerator. I live in Silicon Valley, and I remember going to a Fry's Electronics and seeing these types of things and going, oh, that's really cool. I'm not sure how practical the use cases are, but it's a really cool idea. The iPhone comes out in 2007, and then we just see a whole bunch of stuff. Self-driving cars. Dublin, Ireland becomes the first IoT city. And now we're seeing global IoT sensors tracking everything from traffic and weather and agricultural systems and temperature and how humans actually move in different environments, and just massive amounts of data being fed up and analyzed into satellite systems from disparate IoT devices. Absolutely tremendous. It's $1 trillion market, and there's just billions and billions and billions now of connected IoT devices, far more than traditional IT devices, of course. But even with all this great innovation that we've had throughout these many centuries, we see people trying to exploit them, right? So this is a security discussion, so I really want to jump into sort of how innovations are often taken advantage of. And I thought a really easy way to look at this was look at when the commercialization first kicked in for a certain advancement, and then when somebody tried to exploit it. So the first example, pretty low tech by today's standards, but using the sea for trade. The first commercialization of the sea, when somebody says, hey, I have some stuff over here, why don't we stick out on a boat and sell it to these folks over here? First records are about 3000 BC. That was in the Mediterranean Sea. The first pirates weren't recorded until about 1300 BC. That's about a 1700-year threat window. That's a pretty big threat window when somebody said, why don't we just rob that boat? Then we moved from sea to air. So in 1859, John Weiss had this idea. He would go ahead and move things like mail and other things of that nature via hot air balloon. Really cool idea. It crashed and burned. It literally crashed and burned. But we didn't have the first hijacking until 1931, and that was actually in Peru. The first commercialization of space in the form of satellites was 1962. We haven't seen a lot of exploitation in space as it relates to satellite exploitation or satellite warfare, if you will. There have been some isolated cases. In 2015, there was the Trula data theft, which had a command and control system that leveraged satellites. But the juice really isn't worth the squeeze in most cases. That's kind of the realm of nation states, and we just haven't seen a lot of satellite warfare happening. Next is the commercialization of the internet, right? Roughly around 1988, that's when NSFNet and MCI Mail said, hey, you've got email users, we've got email users. Let's charge them and they can email each other. What a novel concept. Right about the same time, we had the Morris worm. And some of you might be familiar with that, but it took advantage of R commands and finger and things like that, and very quickly propagated amongst connected devices, far quicker than it was supposed to propagate. But that set the threat window to about 0. So we started at about 1700 years, and now we're about 0. And now we talk about the commercialization of IoT. This one's a little bit harder to pin down, but it's roughly about 2010 when it became commercially popular. We'll just say that. In about 2016, we had the Mirai botnet. And I'm going to talk a little bit more about that later, but that's considered by most people to be the first IoT malware, first IoT relevant attack. So let's just jump into some of the statistics now. So again, Phosphorus has been researching organizations since 2007, millions of devices, Global 2000s, Fortune 500s, government agencies, large enterprises all around the world. And what we found is about 67% of the organizations we work with have had a known IoT security breach. Now, we don't have great statistics on the breaches we don't know about, of course, but I'd hazard to guess, and I think you're probably thinking the same thing, that number is probably a lot higher. They're just not aware of it because there's not a lot of situational awareness when it comes to IoT. But, almost 70% of these devices or almost 70% of these organizations have had a known breach related to IoT. And we talk about IoT breaches, it's all the same stuff that you think about on the IT side. Devices can be compromised with malware, they can be added to botnets, they can be leveraged for ransomware, video cameras can be turned on to the people that installed them, and the audio is turned on and they're actually siphoning information off. They're taking video feeds and spying on these individuals. Oftentimes people will use the compromise of an IoT device to leapfrog to an IT device. We've seen cases where devices have been compromised and an IoT device, they grab sensitive information via various hacker tools, if you will, take that information back to that IoT device, compress it up, and siphon it out the organization to steal sensitive data. And of course, there can be physical issues as well, unlocking doors, shutting down power, turning video cameras off again, these types of things. So the same cyber attacks we see on IT, we also see on IoT. And IoT can sometimes be used as a leapfrog to IT attacks. In addition to that, of course, IoT attacks can have a big impact on the physical world as well, all the way up to and including asset destruction in some cases. So a couple more stats here. We started talking to security teams to figure out, hey, do you folks really have your arms around at least an inventory? Do you know what IoT devices you have? About 20% said, yeah, we can identify most of them. 80% don't really have a good clue about what devices they have. And one of the reasons is there's just so many, and there's so many different groups that deploy these in different organizations that they just don't have an idea. On the positive side, though, they realize it's a security issue, and almost every organization has started increasing spending as it relates to IoT security. So that's a positive note. This slide, I just said, yikes. I didn't really know what else to call it. So I went over to Shodan, and I think most of you are familiar with that, the Shodan search engine, to see which devices are internet accessible, if you will. And I just typed in a couple terms that you would think of for IoT devices. I've got camera, voice over IP, printer, and UPS. So not very scientific, just typed them in. But what we find here is almost 5 million cameras, over 250,000 voice over IP phones, 83,000 plus printers, and almost 14,000 UPS systems, which, oh my gosh. And the thing about UPS systems, I won't tell you, but you can Google this. The password is almost never changed, and it's a very, very simple password on these. It's actually the same credential for username and password on these devices. I don't know why they would be exposed on the internet. But IoT devices don't need to be exposed to the internet for these attacks to happen, but certainly the fact that many of them are increase the likelihood. Also, we're seeing a lot of nation states now paying attention to IoT and investing quite a bit. And this is globally. So Russia has this tool called Frontin, which was developed for them by some contractors, specifically for the Russian FSB. And this was an IoT hacking tool designed to find, compromise, and compromise IoT devices, install command and control software, and do whatever they wanted from that point, or also use that as a jumping off point to get in deeper into organizations. Interestingly, a hacking group called Digital Revolution got their hands on Frontin and released the code, so you can get it from torrents and all the places that you like to get your hacking tools from. Another interesting case is there have been IoT devices that have been banned. Actually, the U.S. House of Representatives has passed bills that prohibit federal agencies and contractors from actually using certain IoT devices. So, I mean, they're that well known to have that level of vulnerability that they're just not allowed. So let's just jump into some stories from the trenches. These are always really interesting. And I mentioned earlier Mirai botnet. So for those of you who aren't aware, again, that's from 2016. I'll go a little bit deeper. Very, very simple attack. Essentially, some attackers scanned the internet. We just saw what you could do with Shodan, looking for specifically video cameras to start with that were running Telnet, and they're running Telnet on port 23 and port 2323 on these video cameras. And if they found one that they could get access to, they tried the default password, and they tried a handful, I think about a half dozen or a dozen very common passwords as well, if the default password wasn't being used. Well, what was interesting is there was a lot of devices that were, one, accessible, two, they were accessible via Telnet, and three, they were running a default or very common password. So there was enough of these devices taken over to actually create a pretty big botnet. But one of the issues that's unique in IoT is organizations and manufacturers that make IoT devices aren't necessarily software development organizations. They don't have a secure software development lifecycle. In fact, a lot of the times they just want to take this thing and they want to get it online, however they do that. So they do it on the cheap, they do it as quickly as possible, and they use a lot of shared libraries. There's a lot of white labeling done where I'll grab this component and that component because it's all about speed. I just want to put this thing online. Certainly security is not an issue. So when it came to Mirai, when they found all these cameras with this insecure build, what they also started finding, what these attackers found, was that there was voice over IP phones and printers and other devices that had very similar configurations. So they got added to the mix as well, and it wasn't just cameras. But fast forward now that they've got this huge botnet that they're controlling, cameras, printers, voice over IP phones, so on and so forth, with their command and control software, and they launched DDoS attacks. And they're actually able to severely disrupt pretty big tech companies, Twitter, PayPal, Netflix, GitHub, and some telecoms and many, many others. So again, this was a super simple attack. It's hard to even call it an attack. It was more of just like a search. And then they uploaded some malicious software and they caused great harm. And that was with Mirai botnet. Now the sad thing is, because the half-life of most firmware, meaning that firmware usually sits there vulnerable on these devices for a very long time, and passwords are often pretty weak or default, means that there's devices today that are still vulnerable to this specific attack, and it's still floating around the internet, even though it started back in 2016. Even worse, there's still devices that are compromised, and they're running the malicious code, and the organizations has all these cameras or printers or phones or whatever they have that are infected, and they don't even know it. Right? So pretty sad state of affairs. So passwords. So this is a really interesting thing. When we think about passwords or just credentials as a general term, it's like the most basic step in security. But what we find is about 50% on average of the devices we encounter have default passwords. Now, while that's the average, there's some interesting skews to each side. There's some audio-video equipment IoT devices, for example, where we find about 95% of the time it's default credentials. And then there's some other devices as well where when you install them, the default password has to be changed as part of the installation process, which is generally a good idea. So there's some different sides to this curve, but sadly, when we do find a device that's not a default password, and in fact the password has been changed, one, it's usually not changed to something very good because, again, people just have so many IoT devices. They tend to give them a very simple name and they give everything the same password. But usually the password was only changed once. For that printer, or that KVM switch, or that rack, or that UPS system, maybe it was changed at the point of installation 5-10 years ago. Who knows? But another problem is about 100% of the passwords are out of compliance in terms of how often are they rotated, every 30, 60, 90 days. Usually they're not. Are they centrally managed? Probably not. There's probably no PAM integration with like a HashiCorp, Thycotic, CyberArk, tools of that nature. And then the complexity's off, right? Maybe it's just ABC 1, 2, 3. It's not uppercase, lowercase, numbers, special characters, all the things that we know as best practices. So here's an interesting case. We were working with a financial services organization that was involved with stock trading. And they had these atomic clocks. These were actually cesium clocks. And all these devices I'm showing, by the way, it's not the actual brand that popped up there. This is just a photo to give you a representation. But what was interesting here is they knew about 6 of these clocks. And these aren't cheap clocks. They're about 12K each, which isn't expensive for some organizations, but it's still quite a bit of money. But they knew about 6 of them. We actually discovered 15 of them. So more than half, they weren't aware that they had them. So they had all these cesium atomic clocks, and they're very important for their role. And as many of you probably know, if I buy a stock and you buy a stock, and you get a 2 millisecond advantage over me, that can have a dramatic and profound financial impact, right? So they're really important. What was interesting about these clocks is there were no CVEs on these. And I don't want to say it's because they were ultra secure. They were good devices, but they're pretty esoteric. So not a lot of people are poking them and prodding them. It's not like a common printer or camera or something like that. But what was really interesting, again, was the inventory issue. They just had no idea they had those devices there. So because of that, there was nobody watching the security, making sure they were updated. They had strong passwords and that sort of thing. So a lot of the time, it's just knowing what you've got. And in our research, what we've actually discovered, and these numbers actually blew me away before I really started getting involved with these organizations, there's about 3 to 5 IoT devices per employee. So this is the craziest looking possible chart to show that. But if we just look at 10,000 employees, for example, 10,000 employees, you probably have somewhere between 30,000 and 50,000 IoT devices. That's a lot of devices. And it's way more devices than you could possibly manually manage in terms of taking care of the firmware and taking care of the passwords and turning off unneeded services. It's just completely untenable. You need automated tools. You need a centralized process to handle that. But it just kind of shows you the breadth and depth of this problem. Now, if you look at law firms, for example, they'll have a little bit less. You look at retailers, they'll actually have quite a bit more. So it kind of depends on industry, but on average, take a look at your organization, there's probably about 3 to 5 IoT devices per employee, right? And we'll get into some of the IoT devices that we see quite a bit of in the worst offenders, and you'll start going, oh, okay, yeah, if I start including these things, I can completely see how that goes. And just like with the stock exchange, we were talking about those cesium clocks. When we go into organizations to do a proof of value, and we say, hey, how many devices do you think you have, IoT devices? And they'll say, I don't know, I have X. Almost 100% of the time, their numbers are off by about 40 to 60%. So again, they just didn't know about half of their devices in their environment. So we talked about printers a little bit before. Printers are really a special case because everyone's got them and everyone's got a lot of them. We work with some folks in the hospitality industry, for example, where they have tens and tens of thousands of printers, just printers, different models and brands and versions and things like that, but they have lots of printers. Now the thing about printers is most sort of enterprise level printers have about a 20 gig hard drive. It's not huge, it's not small, but it's a pretty good sized hard drive. And what had happened is some attackers had gotten access to these printers, which, by the way, most of these run common operating systems like Linux or Android and things of this nature. In fact, across all IoT, a flavor of Linux or a flavor of Android is by far the most common thing that you'll find. And by the way, they have a lot of the same capabilities, services. In the case of printers, however, they're far more promiscuous in running so many different protocols. They've got every protocol imaginable because they want to be easy to use. They want people to be able to connect to them and use them. It's the point of the printer. So from that perspective, it makes great sense. But attackers know that, and because they know that, they take advantage of the fact that those printers are so promiscuous and there are so many ways to connect with them. So in this particular case, some attackers had gained access to the printer. They had uploaded some of their tools. And this was only to a few dozen printers at the time, but it did expand greatly to hundreds later on. And they used those to go out searching for other critical devices on the network, IT devices primarily. And from them, they were extracting data. This was all about intellectual property theft. They were extracting the data, and then they were storing it on those 20 gig hard drives. And I'll get to what happens next. Well, a lot of this activity, because it was all being controlled through various remote connectivity controls and C2 and things of that nature, it created logs. And those logs were showing up in Splunk. And they were anomalous. And they said, hey, we've got a lot of printers that seem to be pretty chatty, and we're not really sure why. And then what they were seeing was data exfiltration. And these printers they were being set up to exfil data over ICMP. Why? Because everybody allows ICMP out. And even if it's shut off, network ops turns it back on to do some testing. They forget to turn it off. Just a really easy way to exfiltrate data. You have to make the packets pretty small. Takes a little bit longer, but it usually goes under the radar. So they were using these printers to grab IT-sensitive data, compressing it up, exfiltrating out over ICMP, which eventually caused some alarms to go off. And what they found was when they started looking at these printers and they say, God, it's not just one or two, we have several dozen now, more than 100 now, they're infected. It was just the firmware. They're running really old firmware. Some of these devices hadn't been updated in up to 10 years. Most of them hadn't been upgraded for about 4 or 5 years at least. So they were just sitting there vulnerable. They were doing their job. They were working fine as printers. And usually most people don't pay attention to a printer until it stops, well, printing. So the fact that they were running all this old firmware just made them a big target with a big juicy hard drive and an easy way to exfiltrate that data out. Now, talking about firmware, about 26% of the devices we counter have end-of-life firmware, meaning that there's just nothing we can do with that firmware. It's completely end-of-life. If you're running it, you have to get on a newer version of it. Of the remaining 74%, the average age was 6 years old. Think about your smartphone. It probably wouldn't work if you hadn't updated things in 6 years, and I'm almost certain it wouldn't work. But now you're talking about your enterprise devices, again, all of your key systems, especially the systems that manage other systems. And that's really a scary stat, because if we think about it again, there's not a lot of difference between an IT device and an IoT device in terms of capability, network access, and the type of negative ramifications it can cause upon your environment. And again, with IoT, you can even cause physical harm. So if I went and told you 26% of your IT devices were our end-of-life firmware, you'd jump off this video right now and you'd go fix those. That's how serious this is. So here was a case that I thought was pretty interesting too. This was very recently. This was a DDoS attack against a Microsoft Azure customer. And they had a little over 10,000 IoT devices that were compromised. And there was no real specific sort of vulnerability that was being compromised. It was just general vulnerabilities that tend to sit on these systems. A lot of them run high-level vulnerabilities, and they have a lot of open services to get in. They're running clear text protocols like FTP, TFTP, Telnet. They've got things that maybe they don't need to be running in terms of various services, old TLS, self-signed certs, all sorts of vulnerabilities just in terms of the services they're running, their configurations, and of course any native vulnerabilities. So there's no really rhyme or reason to say it was just this version of a KVM switch that was exploited and used for a DDoS attack. But what was interesting about this particular attack against these Azure customers was that it ended up being 3.4 terabits per second. Now, a 3.47 terabit per second DDoS attack is the largest DDoS attack in history. Not the largest IoT DDoS in history, but the largest attack in history, regardless of IT or IoT. So again, this just gives you a sense of the power of these devices. And once you grasp that it's just a Linux server, yeah, it acts as a camera or acts as a UPS system or acts as a rack, whatever, but it's a computer. So they have these capabilities and they can cause these negative ramifications. So when we start digging into the actual statistics around the vulnerabilities, what we found, and this is probably one of the most frightening statistics so far, the CVSS scores, so scores of 1 to 10, 10 being the most grievous, 50% of the devices have a score of an 8. An additional 18% have scores of 9 or 10. These are high to critical level vulnerabilities. These are the type of vulnerabilities where you don't need local access. You can do remote exploitation. They're very severe. The great majority of the vulnerabilities discovered on these devices were 8s, 9s, and 10s. That's a scary thought. Again, this is one of those things where if these were your IT devices, you'd be like, oh my God, what can I do? But because IoT devices historically have been so hard to first of all, just discover, then manage the passwords, address the vulnerabilities in the patching and the firmware, manage services, etc., nothing's been done. And I guess a good analogy for this is IoT security today is kind of like IT security was in 1995. And this is right about when I started my career in security. But there's no inventory, or very little, or was kept on a spreadsheet somewhere manually. Poor passwords, There was a password policy that was written by your InfoSec team, but it was just a policy. And there was poor patch management, right? It just wasn't taken care of. That's the same thing we're seeing on IoT today. We've gotten past most of these issues by and large in the IT world, but in the IoT world, we're still stuck in Coolio's Gangster Paradise Xena Princess Warrior timeframe and Windows NT 3.51. And I remember when I started, just to kind of frame sort of what, the types of projects back then, my first project, and a lot of you might recognize this US robotics modem here. I was on this project called UMAP, the Unauthorized Modem Abatement Project. What a great acronym. All it meant is, hey, we have all these modems around our campus. We've got to figure out if we need them because they're backdoors for hackers, and they're going to get in and do hacker stuff, like Angelina Jolie did as Acid Burn in Hackers, right? So that was the project. So I used this tool in that next picture, which is Tone Loc, which was written by Minor Threat and Mucho Moss and ran under DOS. And I actually would scan the entire phone system and PBX lines to figure out which ones were responding as a phone, a fax machine, or a actual modem. And then based on that, I'd have to physically go hunt it down and figure out who owned it and say, do you need this or not? If you don't, I could unplug it. So I had literally boxes and boxes of these things. Not as nice as some of these US robotics ones, but some pretty bad ones. Also at this time, we were going to start scanning for vulnerabilities, which was somewhat of a new concept. So I had this tool that Dan Farmer wrote called Satan, Security Analysis Tool for Analyzing Networks, which is how I learned how to write Perl, because the whole thing was written in Perl. And I ran it on this Sun Spark 1 Plus pizza box, which is kind of hidden behind my video there. And that's what I used for scanning for vulnerabilities. And we said, hey, you know what we need? We need a firewall now. There's this thing called the firewall. We're not just going to use access control lists in our routers. So I actually turned the device that I was doing vulnerability scanning on. I didn't take Satan off of it, but we actually threw a couple NICs on there, or one more NIC, so we would have two. So that became our firewall. And I loaded Checkpoint on there with 3.5-inch floppy disks. So the device I was using for my firewall was actually the device that we were also using for vulnerability scanning. And then we eventually threw a third NIC on there because that was our DMZ, because we're super secure. It was crazy. We didn't know what we were doing. We were just doing stuff. But again, that was IT security back in the mid-90s, and that's kind of where IoT security is today. So now let's dive into the biggest IoT offenders. And these are the devices where we see sort of the most grievous issues across the board. Now, we see a lot of other devices that I'm not listing here, but we just had to sort of condense it into the ones that keep on ringing out as being problematic. Again, the pictures that you see here are not the actual brands. I'm not going to call anybody out here. That's not the focus here. But KVM switches. Again, most of you are probably familiar with KVM switches. But a KVM switch, you stick it in a rack, you connect it to multiple computers, and it lets you control keyboard and mouse and video, and sometimes you can cycle power as well. We come across a lot of these devices that are running like Linux Ubuntu version 10. Well, that's from 2010. Right? I think the latest version now is 21 point something. It's a little bit past 21.1. So it's running old stuff. And because of that, it doesn't just have a few, but they have hundreds of vulnerabilities. Now think about this. I've spent a lot of money on my endpoint security and application security, identity this and network security that. And now I've got this KVM switch that can backdoor into all these devices, running a version of Linux that's more than a decade old, that if I'm an attacker and I can compromise that, I can do a lot of malicious things to those devices that are connected. I can probably power them off. I can change configurations. I can, modify stuff, steal stuff, whatever I wanted to do. So that's a huge backdoor. And that's one of the reasons that a lot of nation states, and we talked about Russia earlier, are building these tools, because why bang your head through the firewall and the IPS and the encryption that and application security and endpoint security when I can just go around that back door? Again, like 1995 with that US robotics modem plugged into the back of that Windows NT 3.51 server in the back of the data center that everybody forgot about, right? So KVM switches, one of the biggest offenders that we see out there. Another big one, lights out management controls. So if you look at the back of this server, we see a couple Ethernet ports on the right and something that looks like an Ethernet port where that arrow is. Well, that's not an Ethernet port. That's a lights out management port. Right? That's what you're going to use for management of these devices. Well, the thing about these is there's a few different flavors. There's HP has ILO, Dell has iDRAC, Supermicro has IPMI. So there's a few different flavors. Those are the main ones. They're just little Linux servers. In fact, there's malware specifically designed to target those little Linux servers for lights out management systems. And again, like the KVM switches, but a little bit more powerful actually, these lights out management controls bypass all that other security that you've put on top of that server. So you could have $10 million of endpoint security on top of this thing. But if that interface isn't secure, if it's running a default password, for example, or a weak password, or it has a vulnerability in it that can be exploited because that version of Linux or VxWorks that's running on that has not been updated in the last 10 years, that's a problem. Because now as an attacker, the things I can do for that is I can shut the system down, I can change the network settings, I can run a shell. Some of these guys I can pop open a virtual terminal as well. I can upload software or malware. I can do all the bad stuff that an attacker would want to do. And again, most of your critical servers are going to have these devices. And some people say, oh, well, you know, I didn't even know that thing was there. And that's the problem, again, because there's no good inventory for discovery for a lot of these products. Server cabinets and racks. This is another one that people tend to go, oh, those do have a lot of IoT devices. They sure do. UPS systems, which are notorious for having the vendor's default password, which takes about 5 seconds to find if you Google it. Cooling systems, cable management, tamper resistance sensors, and all sorts of other things, depending on how fancy that rack happens to be. And they're really cool and they're really capable. They're almost always running the oldest firmware known to man. And the reason for that, I think, the primary reason is if I want to upload all the firmware on my rack, including my UPS system and everything else, I need to reboot that system in most cases, which means all those devices that are relying on that, switching gear, routing gear, computer systems, etc., they're going to have to be rebooted as well. So there has to be a change window. And when people schedule change windows, they don't always think about IoT devices, unfortunately, which causes this problem. So these devices are frequently vulnerable. And a lot of these are also tied to KVM switches that we talked about earlier, exposing you to a lot of problems. Physical access controllers. Here's another case where you probably have oodles and oodles of these throughout your environment, whether it's biometrics or a PIN or a scan card or a CAC system, whatever the solution might be. Again, these are Linux devices that are running on the network. And in one particular case, we're working with a customer, and they had this system deployed. It was all default passwords, but if those passwords were not default, and it's crazy to find the default passwords on door locks. It's crazy to think, but you always find it. They had 3 critical CVEs. So had that default password not been there, it would have been easy enough to get through one of the critical one of the 3. You could pick the one that you like most to get into that system. And we're sitting with the CISO and their team, and we're actually able to show them with a click of a button, we could have locked or unlocked all 6,400 door lock systems that they had throughout this financial services company. And again, the IoT devices can have that impact on the physical world. Printers. We talked a little bit about printers before. They're certainly one of the most commonly attacked devices, especially from nation states, but cyber criminals like them too. If any of you were at Black Hat back in 2019 in Vegas, there was some research that was released where they found critical level vulnerabilities. Again, these are level 10 vulnerabilities on over 10,000 different printer types and brands. And there's just so many different types of printers out there, but that's pretty incredible. Over 10,000 devices had critical level vulnerabilities. And again, they're highly promiscuous. They're running a lot of services. They've got wired and wireless connections. They probably have Bluetooth. They might be running other protocols as well. You can manage it via HTTPS or SSH. Some of you can telnet into. They're just very, very open, and that's taking advantage. And again, because a lot of them have that big storage drive, it's great to use them to attack IT devices and exfiltrate your data out the way we talked about it before. But again, it's one of the biggest targets for state-sponsored hackers. I would say it's probably in the top 3. Next one, voice over IP phones and video conferencing systems. Like printers, organizations have a ton of voice over IP systems. And even when people weren't at at the office. There's still so many active IoT systems that we actually saw an uptick in the number of attacks on IoT devices. But now, I guess they're calling it the Great Return. Here in Silicon Valley, we see, the likes of Apple and Facebook and Google. People are all going back to work again. Traffic's increasing because of that, which is usually a pretty good sign. Probably an IoT device could detect that. But there's a lot of these voice over IP phones, and they're usually running a flavor of Android. What we find with a lot of these devices is they've got undocumented SSH administration capabilities running on them with default credentials again. And a lot of this goes back to what we were talking about before with the manufacturers of some of these devices aren't necessarily software development houses. They're more, they manufacture things, sometimes like farm equipment and things of that nature. So they have a small crew. They're not putting a lot of time and effort into testing, certainly not looking at security. If they are, it's very little. And because of that, they're saying, well, I'm just going to white label that. I'm going to use that library from that group. And they might not even know they have that undocumented SSH with default credentials, right? And it just got rolled out that way because they hadn't done that level of testing. So that's a pretty scary thing. With this one organization, I guess you can call this a beacon of hope, but maybe it's kind of sad. They had 31,000 phones. Only 700 had a critical level CVE. As we know, it really only takes one. So these, again, are an example of something that there's just so many. They're so voluminous, 31,000 phone systems. If you wanted to upgrade the firmware or rotate the passwords every 90 days that you use for managing those or whatever steps, it would be impossible to try to do these things manually. And then the last group I wanted to cover were our security cameras. These suck the most. There's so many of them, and there's so many problems. Again, some of these cameras ship directly from their manufacturers with the malware already installed. So you skip the middleman. You just go straight to being infected and having your device controlled. These cameras have been known to actually turn on when they're supposed to be off. They're known to record audio when they're supposed to be on mute. And they also take these streams and they can pipe them back to various countries. So that's a problem right there. And again, a lot of these devices have been banned. But cameras are devices that, if they're compromised, they can certainly be used for spying. We mentioned some of the attacks that are very common in IT and IoT and how they're the same, from ransomware to data theft, DDoS, command and control, malware distribution, things of that nature. One case we were working with a customer, I think they had something like 9,000 or 9,500, a lot. They had a lot of video cameras. And they had been cryptojacked. Which most of you probably know that means I want to take this device and I want to use it to mine crypto. So they had all these cameras that were doing crypto mining. And the way they detected it, I'd love to say it was some cool SIM tool or alerted this. It was their power bill. Their power bill was really, really high, and they didn't know why. If you've ever looked at organizations that do crypto mining, it's pretty energy intensive. So that's how they found it. These guys are usually running Linux, usually some form of like BusyBox, which is a common piece that's on there. And the thing that's interesting about video cameras is a lot of the older ones are designed so I have 10,000 cameras, but they all have to have the exact same password that's talking to the management console, like something like you see here in the middle. Which is an architectural flaw. I mean, you could set it up, and there's some newer ones where you have the streaming password is the same, but the management password's different. So it has two different passwords because of that issue. So when you're talking about password management on these things, you have to keep in mind that, hey, if you are going to change the password and use something complicated, now I have to do it for all 10,000 devices, and it has to be the same thing. It has to be a group password. Again, from a security perspective, not a great design, but sometimes you have to work within the limitations of those devices as well. So again, virtually every organization has hundreds, if not thousands, or even tens of thousands of these types of devices. There's often finger pointing when it comes to cameras. Well, I thought facilities took care of that. No, I thought IT did. No, I think it was supposed to be security. And it's kind of like Spider-Man, right? They're all pointing at each other. It's just very commonly targeted, and they tend to be very easy to take advantage of. And on the consumer side, again, we're not focusing too much on the consumer side here, but one of the most popular cameras on Amazon last year, the most popular camera, highest rated, approved this and that, shipped with malware already installed on it. So it wasn't some esoteric device that you probably wouldn't come across. So now let's get into Star Wars and what we can learn from Star Wars as it relates to mitigating the risk for IoT devices. I think there's some good lessons learned here. So the first thing is discovery. We need to know what we've got if we want to be able to remediate these risks. You can't remediate without discovery, so discovery is very important. And there are some old school ways that have been done historically to address discovery that aren't horrible, but they don't really scale that well for IoTs. Take NBAD solutions, which are, off of some span port sniffing the traffic. Most IoT traffic, thankfully, is encrypted. So if you're sniffing the traffic and all you're getting is encrypted data, you're not getting very much information. Plus, the information that you can glean from sniffing a device, it might tell you I'm a printer, or maybe even I'm an HP printer, but it's not going to get down to the detail that you need, a version, model, firmware, what are the dynamics of the credentials, services, etc. that you need if you want to do remediation. Knowing that something is a printer isn't a very good gauge. So the NBADs tend not to work that well. Also, legacy vulnerability scanners, things that are really designed for IT, such as the Qualys, the Tenables, the Rapid7, they're great at what they do, but usually they work by sending malformed packets when they're trying to do discovery, which is fine with IT. With IoT, if you send a malformed packet, especially on the OT side of the world, where you really don't want to be scanning most of the time, you can knock that device offline, which impacts availability, of course, because it's offline, has all sorts of other ramifications. So that's not a great approach for IoT. And a lot of inventory discovery systems as well, they'll just look at the MAC, more specifically the first 3 octets, the OUI, the organizationally unique identifier of that MAC address. And when they do that, they says, oh, you're a Jet Direct, you must be this. Well, that doesn't work great in IoT. There's a lot of false positives because that MAC identifier could be the same for a printer or for a phone or for a voice conferencing system, or a million other things in between. So there's lots of false positives with that. So it really doesn't work very well. So some alternatives are like enterprise IoT security platforms. And some of the things that they do is they can do something like a very short port scan, check out some various ports, and then do a banner grab to kind of get a level set of, hey, here are some of the devices on the network that look like they might be IoT devices. Or they can jack into these NBADs and vulnerability scanners and other asset inventories to kind of create that jumping off point. And they say, okay, in your environment, we think there's probably around 50,000 IoT devices based on the scanning and based on these integration pieces. But then it goes to the next level, which is called interrogation. So this is the part where it's like C3PO. Instead of bombarding it with malformed packets or trying to sniff devices, what we're actually doing in this case is we're speaking the language of that device in its native tongue. So you're talking to the printer the way it wants to be spoken to. You're talking with the KVM switches, the gunshot detection device, the elevator shaft, HVAC systems, whatever they are, in that language, right? And based on doing that, you're doing interrogation, either authenticated or unauthenticated, to glean all those details, firmware, serial number, what they're running, etc. And that allows you to scale, because now very quickly you're ascertaining what these devices are that I have with a tremendous amount of detail. And the cool thing about this is you have a unique identifier. So as a device switches from wired to wireless, well, the MAC address changes, but so does the IP. So you're not pegged to that IP address or that MAC address. You're actually fingerprinting that actual device based on its scalability of its capabilities. So being able to speak the language of the devices is really, really critical. And there's a lot of complexity and subtlety that has to happen behind the scenes. But from your perspective, you're essentially just running a scan and letting it do its interrogation of those devices. That's why enterprise IoT security platforms are really so popular. Now I've discovered all these devices, I want to look at hardening and upgrading these devices so they're not on vulnerable versions of firmware. So again, back in the day, a lot of people would say, well, I'm just going to throw everything on a VLAN. Well, that's nice, and I don't think VLANs are bad. I think they're a good approach, but the problem with that is, again, you have 3 to 5 IoT devices for employees. You probably don't even know what you have. So trying to put everything on a VLAN, first of all, is technically challenging to scale that, but it also can be extremely expensive. And we're talking millions of dollars in this approach to be able to VLAN all those devices, and you're still going to miss stuff, and there's still going to be misconfigurations. Now, at the end of the day, the worst part is you're not fixing it. It's like saying, oh, I just cut my hand. So instead of going to the doctor and getting stitches, I'm just going to put a plastic bag around it. Well, I'm not getting blood on my other hand, so that's good. But at the end of the day, I still have a cut hand in a bag. That's kind of what VLANing is like. You still need to fix that device. You still want to make sure that the firmware and the credentials and everything are secure. So once you find these devices with these enterprise IoT security platforms, you can harden them. You can say, look, run SSH, don't run clear text protocols. Run wired, don't run Wi-Fi. Don't run Bluetooth or Bluetooth low energy, BLE. Shut these things off. Now push those out to all my printers or all printers of this version or everything in building A. So you can do hardening. So that's good. So that reduces the attack surface down greatly. The next part is firmware. Well, it has to be agentless because you can't put agents on IoT devices. That's one of the reasons that traditional IT tools don't work. So you need this centralized agentless structure, such as an enterprise IoT security platform, that can in an automated way go out and upgrade the firmware on these devices. And usually the way that works is these devices, these enterprise IoT security platforms, they run on-prem usually or from a cloud, like a private cloud like Amazon, for example. Most of them have been Dockerized. And they run from these environments, and they have all the firmware, old and new, sitting in like a Google Cloud. It's all been cryptologically checksummed, all the communication's encrypted, they've been verified, so you've got all these verified firmwares, so you don't have to hunt the firmware for this device and that device and that device, multiplied by 50,000, try to find it, then go ahead and upload it to the device and figure out, how do I actually communicate with this device? How do I have to upload it? It's a nightmare. It could take you an hour or more per device, easy. With this model, that firmware is in the cloud. If you want to update 5,000 printers at once or during some change management window or everything in building A today and building B tomorrow, however you want, it makes it very easy. And in some cases, you want to even downgrade it. You go, oh, well, I'm on version 5 of my firmware, but version 5 has a Log4j vulnerability. The vendor knows they're not going to have version 6 for 3 more weeks. But maybe I got to go down to version 3 for now because that didn't have Log4j. So I might want to downgrade that just because Log4j is in the news and everybody and their sister is running these attacks right now. So that can cause a problem. So being able to upgrade and downgrade firmware is a huge gain. Once I discover the device, the first thing I want to do is make sure it's on the latest version of the firmware. And I have to be 100% accurate. You don't want to turn a $2 million MRI device into a $500 printer. So that's why accuracy is so key when you're doing this type of analysis. And furthermore, when you're doing the firmware, some devices let you jump from version 3 of the firmware right to version 6. Some devices say you have to go 3, then 4, then 5, then 6. That's why during the discovery phase and that interrogation, that C3PO process that we talked about, communicating in the native language, you don't just get the information about the device, but all the supporting intelligence about how are these devices upgraded? What's the process? What are their capabilities? The next thing is managing credentials and certs. So I found the device. I've got the firmware locked down. Now I want to address these credentials, these default credentials. So a lot of these enterprise IoT security platforms will integrate with PAM tools, CyberArk, HashiCorp, Thycotic, tools like that. And during discovery, they can even automatically enroll these devices in the PAM, which is pretty cool. And when you're doing this, you can set policies. You can say, look, for all these devices, I want to rotate the passwords every 30, 60, 90 days. I want these passwords to be complex. I want them to be 20 characters long. Well, just like with the firmware, knowing that upgrade path, the enterprise IoT security platform needs to know, hey, you know what? This thing only takes a 4-digit PIN. Or this device can use upper and lower case, but not special characters. Or this device can't use a hyphen or the letter B. We've seen all sorts of crazy things in this world. But knowing that, you can create these policies, again, based on that device. Because you've done that interrogation, you understand what that device can do, just like with the firmware, now you're actually applying the same concept to credentials, which is really nice. And then the same thing can be applied to certificates as well. Because just like that, knowing where the device is or what firmware or password, usually the certs are problematic. It's on like TLS version 1.1. It's maybe a self-signed cert. It expired a long time ago. So by integrating with those systems, you're actually able to validate and ensure that the certificate are strong as well on those devices. So I found the device, I've hardened it, I fixed the firmware, I've got the credentials and the certificates working great, everything's humming along, and I want to make sure that thing that's working now is working tomorrow and working next week, next month, next year in perpetuity. We call that environmental drift. Things always happen, right? Things that were working stop working. Things can be hacked, things can just break, there's mechanical fatigue, there's all sorts of problems that can happen in IT and IoT. We all know that. So if you have an automated way of interrogating, just like during the initial interrogation, usually best practice is to have a daily test from your enterprise IoT security platform that's going to go out and talk to your devices once a day, or maybe one building a day or one region a day, however you want to break it up, to make sure that they're working the way they're supposed to work. If all of a sudden it says, hey, you were on version 6 of the firmware, but now you're back to version 3, or you did have a password that was managed by CyberArk or something, but now it looks like it's back to a default password, or the password was changed and the PAM tool didn't change it because the enterprise IoT security platform has to act as that intermediary between the PAM and the IoT devices, because PAMs can't talk to IoT, but enterprise IoT security platforms can talk to IoT and can talk to PAM. So because of that, it has all that notion of state. Or somebody walked by and committed an insider threat attack, with a paperclip. If you take a paperclip and you walk to the back of a lot of IoT devices, there's a little black reset button. And if you depress that, it sets everything back to the default firmware, default password. And it's called a paperclip attack. So if these paperclip attacks are committed, it's going to drop these things back down. And there could be a valid reason for resetting a box, right? Or it could be malicious, but you don't know at the time. Now, because these enterprise IoT security platforms are integrated with tools like Splunk and ServiceNow and Demisto and other types of management tools and ticketing systems, you're made aware by exception. So you could have 50,000 devices, but now you're aware that, hey, but it was this one device or these 5 devices that changed today or this week that I need to focus on right now. Those are the ones that I need to address. And that's powerful. That allows you to scale. So when you talk about the ability of an automated platform to allow you to scale and address a really vast, complex IoT network that has multiple communication protocols and hundreds of different ways to upgrade firmware and all these different things going on, now you can actually do it. Now you can actually manage those passwords, those firmwares, and monitor those devices to make sure that nothing malicious has actually occurred, or there wasn't some type of fault. So again, really, really powerful capability of having both monitoring for that environmental drift and insider threat, and then integrating with all the tools that you're using on the IT side. So you have your alerting through your SIM, through your ticketing system, through your source systems, things of that nature. And then finally, reporting. So you're doing all this great stuff with all your IoT devices, but now I need regulatory or policy compliant reports that kind of show me where I stand. I want to know, one, can you just tell me how many devices I have, of what device type and version, and grab all that information. Tell me firmware values, what firmware is end of life, what devices do I have actually enrolled in my PAM. Maybe I have 50% and I'm shooting for 90% by the end of the quarter, so you can track that. Services. Do I have Telnet turned on, or FTP or TFTP? What type of CVEs do I have? How many devices do I have that have level 10 CVSS scores, right? Or how many do I have that are 8 or higher? And then I want to break it up maybe based on model. Show me all my cameras. Okay. Show me all my access cameras. Great. Show me all my access cameras that are firmware older than 2 years. So I can get really, really detailed. So having that, those built-in reports is an extremely powerful piece. And then finally, you might want to have all of that reporting capability piped out via API into some of your existing reporting tools that you're using for IT. So that's really, really common. So these enterprise IoT security platforms, generally speaking, are going to have an API capability to integrate all that reporting data out. So you don't have to have a separate report for IoT, a separate report for IT. Things can be integrated. Again, it's all about scalability. It's all about making sure that this isn't going to take a lot of extra time, because there's a lot of devices. I mean, you might have more IoT devices than you have IT devices that you're trying to manage, but you don't want to stack on more and more tools, but you do want more and more capability. So to summarize, IoT devices, they're virtually always vulnerable. I wish there was another way to say that. It just sucks, hence the title of the presentation. Historically, it was really hard to just find these devices. Just say, I don't even know what I have. I know I got a bunch of cameras and some door locks, I think, and I don't know, lights out management. I hadn't even thought of that. But just finding them, that's a problem. Then the next step, of course, is once they're found, remediating the risks, which is the bigger part of the equation, right? I just don't want to find it. I want to fix it. And then I want to keep it fixed, right? So that's really important. And now there's solutions to help with this, right? Enterprise IoT security platforms somewhat of a newer concept in this world, and I put a couple versions down here. Of course, this is something that Phosphorus does, but we're not the only people that play in IoT security. You can take a look at some of these other vendors. Everybody has a little bit of a different approach to this, some a little bit more legacy, some a little bit more modern. But now these tools can help you discovering the device and what vulnerabilities are on my device, updating my firmware, managing those credentials and those certificates and hardening those devices. And then what's really critical is integrating with all my other IT security tools for logging, for SOAR capability, for ticketing systems. And then being able to pull all that together with a reporting capability that makes this easy for me to manage at scale. And if you're able to do this, not only are you able to sort of discover your IoT environment and lock it down, but you're able to do it at scale with these automated tools and make these devices secure. You're just not hiding them off in a VLAN. You're just not closing your eyes and hoping nothing bad's going to happen. And you're greatly reducing the risk on your organization with something that's very easy to do. In most cases, running discovery from these enterprise IoT security platforms is like running a vulnerability scan, right? The firmware is just kept up there. You don't have to go hunt for the firmware yourself. The integration, API integration with the PAM tools is already there. It just works and it just fits. So something you probably want to check out if you're trying to address your IoT security. So again, my name is Brian Contos. I'm the Chief Security Officer with Phosphorus Cybersecurity, and thanks so much for your time.
Thank you, Brian, for your great talk. Up next, we have Security is an Awesome Product feature by Mark Hahn. Mark will be walking us through how to reframe security issues that developers might have and how to foster a better relationship with your organization's security and development teams. So with that, I'm going to turn it on over to Mark.
Thank you. Thank you very much. So welcome to my talk. I am Director of Cloud Strategies, SRE, and DevOps. 30 years of building software, and delivering it and maintaining and operating software for trading companies, supply chain systems, retail payment systems. So a lot of experience in building and delivering application software. And so I come at security very much from an application-centric point of view. What do I as a developer really need to take into account for security? How do I deliver a product that's trustworthy and reliable and doesn't page me in the middle of the night and doesn't have, great big, oh my gosh, what's going on with this kind of problems? So that's the way this talk is structured. It was inspired by a quote that was on the Breaking Down Security podcast, which you should check out. By the way, if you want to follow along with my presentation on as I talk along, you can click on that link, tcbtech.com/awesome. That will bring you to the slides for this presentation as well as the speaker notes. So you can follow along and look through the particular diagrams and so forth with me. But this talk was inspired by a comment that was made on the Breaking Down Security podcast. Teams want to work on awesome features. Development teams want to work on awesome features, not security. But what they don't realize is that security is an awesome feature. It's an awesome product feature. And that's what I'm here to do, is to help you frame the conversation with your development teams that are developing software in your organization as a product feature that brings value to the product, brings value to the organization. So I'm an agile software developer. I've been doing methods like Scrum and Kanban since before those terms were developed or applied to software development. And one of the things that I've tried to do over time is make sure that the software that I build is trustworthy, trustworthy myself. That is, can I actually run this software and not get woken up in the middle of the night, not have managed huge risks from it? but how do I do that? And what are the capabilities? Which is how I got into security in the first place, was that I realized that a lot of the software that I was working with needed much better security controls than I was understood at the time in the 90s. And so learned a lot about security and went from there. So let's talk about awesome, the word awesome. So it's used twice in this quote that inspired me. And so I went and looked it up and said, what is awesome? Why is that term compelling? Why does it apply in this context? And really it is about a comparative, or comparing something to the other. So this thing is awesome, so it's better than something else. And that's sort of the crux of the discussion today, is how do we make comparison about product features and get them into the discussion, so that as we're looking at developing and building a product, we're taking into account the security features as first order product features. So again, I come at this from the viewpoint of an agile delivery methodology, an agile practitioner, a software developer who does agile systems. And so very much at the fundamental process of what we're doing is DevOps or DevSecOps. That diagram at the lower left-hand side there is the Gartner diagram about how to do DevSecOps, which I think is, I like the term DevSecOps, but really that gets kind of complicated. The more you start talking about security, the more that you get complicated diagrams and complicated guidance on how to move forward. And I prefer to think of security much more in a straightforward, simpler way. Empowered teams that are empowered to build your enterprise software or to build your product software should be empowered to deliver the business value that you want from that software. And so they need to have the right set of tools and the right set of capabilities and the right permissions and the right roles to do that. And they need to go from an idea of, here's some software that's going to help us, and get that delivered either as a product or as a running piece of software in your organization. So there's planning that needs to be done: build, test, deploy, monitor, using continuous integration tool sets, using using DevOps, using automation to deliver this, so that they're highly productive and can focus on the things that humans do best, which is being creative, as opposed to the things that machines do best, which is following the plan and deploying software and monitoring hundreds of different software systems that are deployed, that build this, pieces of software that are deployed to build this holistic system. So empowered teams they have the capabilities and the resources at their grasp, whether it's part of their team or other teams that they can rely on to manage the entire process. But fundamentally, the process is very simple. So, and this is, the diagram here with the 5 stages is kind of built on the OODA loop that was developed by the fighter pilots in the U.S. military. And the OODA loop is observe, orient, decide, and act. And that simple process in a very complex battlefield situation with a multi-million dollar, $100 million airplane is the straightforward nature of how to react and respond to your environment. And so software developers need to do much the same thing. So I like the diagram that's on the right, which is a straightforward, simpler diagram. Anyhow, this is all about, though, delivering business value in the simplest, most straightforward way possible. And what we want to do is to describe that value in ways that allow development teams to make decisions that allow them to prioritize security requirements. And so there are many different frameworks that development teams will use to prioritize the features that they're going to put in their product. And we'll talk about some of those that help teams see that the security features that you want to talk about, the security aspects of a system that as a security team you want to see delivered, add value to their product. And so these are the roughly the four categories that we're gonna talk about. Relative value of security features versus other features, monetary methods, how to come up with a monetary framework so that the security features can be prioritized in and amongst the other, say, revenue generating features of a product. Checklists of different frameworks that you can use to say, you've got to do all of these things. And then frameworks that allow you to do modeling around this security features that you want. How does the model of your system incorporate the security pieces that belong in this particular product? So we'll talk about how these different methods of framing value help you have a discussion with your development teams to make sure that security is addressed properly. Relative valuations is simply taking a look at the product features and then looking at what has to be, from a security perspective, what has to be in your product. And so this relative valuations tend to be, I think, more, they're relative. So there's a lot of give and play here. There's not a fact-driven platform that you can go with. This is much more a gut check kind of, where does security fit in gut check wise compared to the feature to have a particular button do something in the product. So but there's some things about relative value that's kind of helpful. Like you might have regulatory mandates. If you're building a system that is dealing with credit cards, you've got, you can't do this unless you're signing the agreement with your card holder, your card processing bank to do the following things. So there's contractual agreements here. There are regulatory requirements if you're dealing with healthcare information, if you're dealing with financial information. These are mandates, right? You can't get away from addressing these things. They're important requirements, which sort of everybody knows. Using TLS and up-to-date cipher suites, I noticed that the browsers have been working diligently over the past 2 years to really remove older crypto choices out of your manuals. The big change from TLS 1.1 to 1.2 is just removing a lot of the cipher suite choices that were available. Using OAuth as a strong way of doing the authentication between systems, enabling multi-factor authentication in the systems. I mean, it still surprises me that my bank thinks that multi-factor authentication is somehow a text message to my cell phone, and not using an actual multi-factor app like a YubiKey or something else. Encrypting data wherever you can, at rest, in transit, et cetera. Setting up session timeouts. So, banks have gotten fairly good at saying, basically, if you're inactive for 15 minutes, you're going to be logged out. But there are other places where timeouts last longer. It's, for various reasons, Amazon will keep you logged in for a very, very long time because it's in their best interest to make sure that you can check out that on one click, right? And whether it's you or somebody who's wandered across your logged in session at the library, that's, what are the correct session timeouts? What are the correct session timeouts for your product? And, there are lots of advice and guidance that you can do here and figure that out. But again, it's a gut check for your product. What makes sense for your product? And nice to haves. Well, so I threw in application firewall as a nice to have, but there's, some of you on this call will say, well, but an application firewall is a must have. It's above important requirements. It's in a hard requirement. That may be the case, but your product team may feel differently, that application firewall is somehow preventing them from doing work, or they don't have the time to implement it. And their gut says it's more important to add a new feature that's going to draw in more users than it is to build an application firewall to protect this product. So having a relative value discussion here is probably the most difficult way to talk to your development team. So there are more factual driven ways to go have a team that allows this discussion to be on firmer ground. Monetary evaluation is one way to do this. And so in particular, like what does it cost if something goes wrong? And so the 2021 IBM Ponmon is excellent for gathering this data and delivering it and sending it out in terms of cost of the data breach. I don't know that their 2022 report is available yet. So these figures come through come from the 2021 report. And if you look in the speaker notes, you'll find the various pages that I've taken these particular amounts from. But when you go to your product development team and you say, look, you're spending $10 million to develop this product, or you're spending, our project budget is $2 million for this piece of enterprise software. And then you come with a piece of paper that says, hey, look, by the way, if there's a breach here, this is what it's going to cost you. And that number is, twice the size of the project that cost, or it's half the project cost for this product. That can be a real attention grabber, right? Getting the full lifetime cost of a user of your system. They might bring in over the life of the system $100,000 in revenue, and the cost of acquisition is $10,000 to bring that customer in. And if you go tell them, yeah, if you add this feature and it's broken, by the way, the lifetime value of that customer is going to go from $100,000 to $2.4 million in the negative, plus that $100,000. So you're $4.14 million in the hole. Like, that's a discussion that your product teams and your product owners will listen to. You can talk about the average cost of a lost record and do some multiplication to show that a cost of a breach, a cost of a security, of leaving out a security feature, not putting in that application firewall that we talked about, could cost a lot of money. That application firewall that might detect an accidental SQL injection attack that's blocked by that firewall, that prevents a data breach, that prevents hundreds of thousands of records of being released at $180 a record, right? So this is a great way to have this discussion. However, this sort of discussion can also be abused in terms of the way that it's done. I was listening to a security podcast, and one of the CISOs was basically saying that anytime a product development team pushed back on a security feature that her security team wanted to have implemented in the product, she would just whip out the GDPR fine amounts. 20 million euros is the minimum fine for whatever security feature. And while that's a really big number, it's also a number that is impossible to sort of describe, to put in terms of the product feature. And so because that number is so far out of whack with, say, a $2 million product to put into the field, because that $20 million trumps it by an order of magnitude, they just ignore it. Like, yeah, sure, you can say that, but it doesn't matter here. So you don't want to bring this out and just basically have the security team shut it down because they're building a product, they've already been funded, and now you come along with this big honking number that they don't really care about. And so what they do is they politely nod their heads and they wait till you leave the conference room or sign off the Zoom call, and end of discussion, they go back to doing what they were doing anyway. So it's important to recognize how to have these conversations and to scale these numbers in ways that make sense to your development team, which probably means talking more, building up more from the average, cost of a record loss. Assume that the number of records lost might be a smaller number that's fathomable by the group, and then have this discussion about ways to prevent that. You're concerned that if you fire up a web application firewall on Amazon, that's costing you $400 a month in addition to the other costs on here, but we can show that the payback for that is reducing the risk of the likelihood of a breach this way, and therefore that $400 is a net win, and our organization can support you on that by taking the time to build that out. So that's a better way to approach this and use these numbers as a discussion point. there are checklists. So this Gartner report, Gartner is a very well respected organization, giving lots of good advice to people. They have multiple lists on security. So this 12 things to get right, I think, was from 2019. A 2019 report there. The link is in the speaker notes if you're following along in the presentation there. This is common. There are a number of different sets of checklists, from this 12 things, which is kind of fathomable, to much longer lists like the NIST SP 800 series of controls, and I think SP 863 has got like 106 controls at my last check. Going through a list like that of 106 things that you have to add to your product feature, when the product backlog may only have 50, 60 features in it, and then you come in with a checklist. Here's the NIST SP 863 checklist. Here's 160 things you've got to add to your product before you can release it. Is a great way, again, to get development teams to sort of nod their heads and wait till you leave the room, and then they're going to go back and do what they want to do. But this is, there's some authority behind having the NIST give you a set of features, the PCI card industry giving you a set of features, Gartner telling you these are the things that you need to do. There's some authority behind there, so it's not just you in the room. It's important industry experts. It's a great way to have a discussion, but it's also some way, you have to use that again in moderation and make sure that you can use that to get level set and get the attention of the team, but then not shut them down because you're carrying too much weight that they can't carry it. So another approach that I've used in the past that was very helpful is the OWASP, Open SAM security model. So you're familiar with the OWASP top 10, which is a great place to start in terms of just sort of remediating, starting with teams that haven't really thought about security. The OWASP top 10, here are things that you should do. Have you thought about these things? Do you know what SQL injection is? Does your tool, does your security lifecycle, your software development lifecycle, does it take into account how to check for and remediate these top 10 things? That's a great tool. The lesser known project at OWASP is the Open SAM model, which stands for Security Assurance and Maturity Matrix model. So it goes through, it's fairly complex. So in terms of, again, I think when you, each one of these boxes here, each one of the 15 boxes here has like 4 or 5 different components on it. So, 15 times 5 is a pretty big number, pretty big laundry list of maturity model processes that you want in your software development lifecycle. So it can be overwhelming, but at least it's got a lot of, good advice on things that you should be doing. It also is a little bit more on telling you what you should be doing and a little less on helpful advice around how to go about do that. How do you do an architectural assessment is not something that's in the Open SAM model, but it is telling you that you've got to go do that. So this is where you can start off with a development team and say, look, here's a maturity model that will get you farther along. When you're looking at a particular thing like secure deployment or an architectural assessment, come talk to us. Like, if you don't know how to do that architectural assessment, if you don't know how to do that piece, come talk to us, because we as security professionals can guide you through that. We'll help you have that discussion, frame that up. So that's this is a great tool, even though it can be daunting. You can use it as a way to, again, in moderation, talk to your teams and start that conversation and show them that you can be the collaborative, consultant for security and how to add security into their product. So these are four different methods of talking about, relative value, checklists and frameworks, monetary, these are ways to start that discussion. But ultimately, teams that deliver, they have to make sure that they're empowered to deliver the security features that are necessary to make a product reliable. Again, my approach has been, the best software is developed by empowered teams that can move fast, agile teams that understand the business space that they're in and have the authority to solve their own problems and move forward. So they don't, when they run into a problem, they don't have to reach out to an operations team. They don't have to reach out to other teams to, set up certificates in their software. They can do that themselves. They can set up, TLS. They can encrypt the data in their database on their own. They can set up, column level encryption. They can set up storage level encryption. And they've got the capabilities in their environment to be able to do that without having to wait, file a ticket, wait 3 days for some operations team to get back to them, and then have, 3 1-hour meetings to discuss how this gets implemented, and then schedule it for release to be had in the following month. That's down the road, right? They can encrypt the data, test it in their test environment, and later that day move that same encryption checkbox in, however they've enabled that feature, deploy that into production, monitor it tomorrow, make sure that all of their workflows are still working as possible. Their business transactions are the same. They can collaborate with other teams, and this is important. So they may not be the be all and end all of, say, looking at how the Azure SQL server in their cloud environment is configured, but they can go talk to their SRE team or their cloud DBA team and ask the question, how do we implement this backup scheme? How do we ensure that our the database is encrypted at rest? And have a consultative discussion with other teams in their organization that understand that particular area of their infrastructure much more deeply. And by being able to do that, they can move fast. And so when they recognize a security need, they can quickly prioritize that and include that in their product without having to ask for permission or schedule it for a long time ahead. They can react to those security needs. And so as a security practitioner, as the security analyst that is recommending things, you can talk to these teams, get the particular features prioritized, and recognize that the advice that you bring will be prioritized. And that's okay, because eventually, as things become important enough, they will get addressed. And not everything has to be addressed at once, because you can't do everything at once. So this is important to recognize that cybersecurity is a business problem. And so this, again, is taken, this idea is taken from a book called Fire Doesn't Innovate by Kip Boyle, who was the Chief Information Security Officer for Safeco Insurance here in Seattle. So Kip, what his point was, as an insurer and as an insurer of businesses that need business insurance, and they were looking at how do they do cybersecurity insurance, what he realized was it was very easy for them to sell insurance like fire insurance. If you've got a warehouse and you are insuring that against fire, like fire is in this century is the same as it was in the last century. Pretty much not much has changed about fire. On the other hand, the cybersecurity threat that you've got this year is totally different than it was, say, just short 2 years ago, right? The evolution, if you read if you go back and look at the Verizon data breach reports, or you look at the the various lineage security reports, you look at a Microsoft trustworthy computing report from 10 years ago and now, like, the landscape is totally different in terms of how that works. And so what his suggestion is, the cybersecurity criminals are innovating, very fast, month over month. They're innovating in the way they work. And so if you're an insurer in this business, you have a very difficult problem. But and that problem is a business problem. It's not a It's not a technology problem. It is a business problem. And how do you solve that problem? Well, the way that you respond to an evolving cybersecurity threat is through development teams that can evolve their product to mitigate those threats. And so you've got to have an empowered team that's empowered to understand their threat landscape and respond to it. And so as you do that, what you're doing is as a cybersecurity person, you're helping that development team become much more important, much more capable, and therefore more valuable to your organization. And each of those developers becomes more valuable in terms of their capabilities. And so this is a conversation that you can have, not telling them you have to do these things because otherwise, there's grave concerns or whatever, but you can do these things, you can make your product more valuable, and you can become a better developer who brings more value to the organization. And that's the way you want to frame this conversation, is around bringing value by building a more trustworthy product. So the little pictograms there is sort of a typical sort of agile team, where you've got a product owner, a development lead, and several developers, and maybe some junior developers. And this is the team that's responsible for delivering a product, taking a product idea and building it and delivering that product to the world in the most straightforward way as possible. Plan a product increment, build that increment, deliver that increment, make sure that product increment works as expected, build that minimum viable product, make sure that you're getting the value out of that, pivot that minimum viable product into something that's different than you imagined, but your data shows that that's the features that the users are using. So enhance those features and make that product, follow what the users are doing. So, your monitoring, your business level monitoring goes into your planning phase and so forth. So this very simple process, security fits into this security process because you can show that those features add trustworthiness, bring more users to the product, and prevent various downsides. And again, it's a business problem. Cybersecurity becomes a business problem and not just a checklist of things that people have to do. So we talk a little bit about the software supply chain. There's also a business value chain. There are lots of stakeholders that have some impact on your development team that they need to take advantage of. Starting with in the upper left there, your senior leadership team that has certain expectations about what this product is going to do and the revenue that product is going to bring. Your business owners, your product development. So you're on the senior leadership, your CIO, your vice presidents, your directors. You've got business owners, your product development teams, your product development owners, your business analysts, your project managers. They all have some say so. Your users have a significant contribution towards the types of business value you want to deliver in this product. Your SRE and operations teams that help your development team deliver the value, help them monitor and make sure that value works right. So you've got your SRE person, your tier one responder, your operations personnel, all of which are stakeholders in making sure that your system is not waking them up in the middle of the night, not over consuming resources and costing more than the value, et cetera. That it's a manageable product. And then you've got information security. So you're just one of the stakeholders. Your team is just one of the stakeholders that's involved in helping this product team, this development team deliver value. You've got your cybersecurity analyst, your pen tester, and your compliance people that have those, industry regulations or governmental regulations in order to deliver this product. So all of these people have conversations, and given that you're, as information security, competing with these others, you need to frame the way that you have that conversation to ways that are receptive and responding to the things that organization, the development team is being pushed and pulled on, and how you can bring value so that you can essentially reduce the complexity of their life, reduce the pressures on them, be helpful in ways that allow them to get their work done better, faster. So by bringing automation, by bringing helping them with problems that they can't solve themselves and helping them solve those problems. You become a partner with this team and you frame things in ways that they can consume the information and the support that you're bringing them. And that's the important part, is figuring out how can they consume the message that you want to receive, message you want them to receive. So my recommendation is that, systems that are built and delivered are delivered iteratively. Like if you look at the growth of just look at AWS. I mean, it started out as very few features, and they continued to iterate on the features that their customers were buying. Azure started out as features that were consumed internally in Microsoft, and then eventually were released to the outside world. Originally, it was really intended to be a platform as a service using just Microsoft, the platform of Microsoft products like .NET, delivered in platform as a service, and now it's become a fully featured, software as a service, platform as a service, and infrastructure as a service. And they've incremented on that over the decade or so that they've been delivering the Azure services. So again, taking an incremental approach, starting with things that are most consumable by your development team, and getting that in the current iteration, getting that in the next thing that this team is going to release, and not try to give them the entire checklist. In your next release, you have to deal with everything that's in SP 863. Here are 106 security controls that have to be built into the next release of your system. That's a great way to stop all project work, right? That's not going to happen for another 18 months. And so whatever product they're building is going to lose an 18-month head start on the competition. So figuring out which ones of those requests are most important, which one of those security controls are most important, and get that in the next iteration and get that delivered. And even helping your team build some of the automation that's needed, the DevOps automation, taking that on and working with your SRE team, or working with the developer that's really interested in installing that Jenkins server, or maybe some other better higher quality DevOps server, but is interested in that. We'll have a conversation with you, get that built into the next iteration, and you can work your way as your team iterates on smaller wins around security. They become more and more capable. They become more capable to take on bigger wins around deployments and around adding bigger features, like doing container scanning, doing a full threat assessment or a risk model of their system, is a great way to, after they've had, you've developed a working relationship on small features that they can implement. Now you can begin to expand that conversation into broader topics and bring them into the fold. Number one, they're in a position to better have that conversation with you because they understand that they can deliver security features. And two, they understand, having delivered some, what remains to be done. They begin to get a good sense of what the security landscape looks like, and therefore we'll have a broader conversation with you, and we'll start having that conversation to help, bringing you to the table to help them evaluate what security feature is next. Should we be implementing a software supply chain system, or should we be implementing OAuth on the front end? Which one of those things is more important? And you guys can help them evaluate that through a consultative approach. So, and what this boils down to is that a system is not going to be used if it's not trustworthy. And so by helping your development teams build trust into the system, you are helping that development team build a system that people will use. And I know for many years, I worked in various enterprise IT shops, and all of their development, and actually, so even working on a project now that kicked off last month, and the project manager brought out the book that said, okay, here are the non-functional requirements that we want to add to your system. And I'm like, I'm sorry, those are all functional requirements. What do you mean that these things are non-functional? We're not going to get to them all at once, and we're probably going to release well before we've addressed everything on that list. But trust me, they're important, they're functional, and we will get to them, but maybe not in the order that you think, and certainly not in a big waterfall fashion that was there before. So don't help your teams understand that. Or let me put this in a different way. When you bring a big checklist, when you bring a big honking scary number, you shut down the conversation. And when you call these things non-functional requirements that must be addressed, like you've sort of, it's a contradiction in terms. These are functional requirements. And if you frame the conversation as here's everything that you've got to do before you can release, you end up essentially throwing down a gauntlet, and you put yourself in an adversarial position, and that shuts down the conversation. You need to come in a way where you're talking about application trust, the next security minimum viable security increment that you can put in your product that will make this product better, right? And let the team decide and work with them in developing a rubric, their own rubric and framework for how do you decide when you've got enough security value for your next release. And that may not be every bit of security value you'd like to see them done, but if it's better is a win. And if you use perfection, it's the enemy of getting a product out the door. So you need to construct your discussion in a way that is incremental and consumable, right? So sort of in summary, and there's still a little bit more down here, is don't boil the ocean. So working back up. So, be prepared to work iteratively. You can't come with a giant checklist. Find the developer that's interested in security and work with them and help them build a beachhead, and then broaden that beachhead of security in the team. As they become more capable, they'll see more value. And this is something that builds over time. Pose security requirements as product requirements, as product features that bring value. So think about ways of not describing features, security features, as things that are net negative or the sword of Damocles that's hanging over the development group that you can't do anything until you've solved this problem, but more as here's a way to bring more value to your product, and here's how we can describe that value, and help empower your development teams to deliver. So I worked with a gaming company many years back in terms of helping them develop secure conversations between the various different components of their system. And so, I showed them where there were going to be problems if the conversation was insecure and how that could be exploited, showed them how to secure that conversation in a way that, how to use cryptography to secure these conversations between two different components, and then wrote some of the code that helped them to do that. And then went on to do some other work with that team, and was very proud of the fact that I was added to an email thread where somebody had said, oh, look, we need to have these other two components talk to each other, and we know how to do that. So let's add this security piece just like we did over here. And I was added to the end of that conversation after it had been released, and they were all done with it and it worked correctly. I got added to that thread, and I thought, well, there's my job, right? I showed them how to do it, and now they've done it on their own without including me. They understand the value of security. They understand how to implement that security. So now they're capable of doing it as well. And, hey, that was a huge success. So if you can have the conversation the way that leads the teams to better, to just include that security on their own, they recognize the problem. They can solve the problem themselves. You've had a big win. And recognize also too that, like, prior to them having recognized this and implemented this feature, they had a security hole. And, you could live with that a little bit for a while because they did have the capability and they recognized it. And so lots of products, in everything, right? So you look at most of the 0 days and, the big things that have occurred in Linux where, the big problem with OpenSSL that was last year, the problem with Heartbleed, like you look at all of these things, they're longstanding issues that have been in the product that are kind of waiting around for people to find them. Don't if we had waited 20 years to release Linux because we hadn't found and fixed all the 0 days in Linux, Linux wouldn't be here. So you still need to get the product out, get feedback on it. So help your teams get the product out the door. Couple of things here. So we talked about DevOps, DevSecOps. So Accelerate is a great book for how to get teams empowered to deliver, how to use automation. The thing about Accelerate is it talks, again, a lot of these tell you what you should do without really telling you how to do that. So the thing on the right there, the DevOps efficiency matrix, gives some guidance in terms of how to recognize whether your DevOps, your DevSecOps environment is efficient or inefficient, and the sorts of things, how you go about improving your efficiency. So the idea is to build a simpler framework that gives you more structured advice on how to go do that. But Accelerate is a great book for reading, as well as the other things that the last author there, Gene Kim, has written. But this book is a great discussion of the capabilities that you need to be able to deliver software. The other book, which I don't think, it's been around for a decade or more now, based on the Microsoft Secure Development Lifecycle, threat modeling, helping your teams. This is not a book that I think the information security teams need to read. This is a book that development teams need to read and understand how to do, threat modeling, how to build data flow diagrams that show where data is moving in your system and where those interfaces are in that data flow diagram, and then how to secure those interfaces. This is a great book for development teams to work with. So working with your development teams, introducing them to this model, introducing them to the STRIDE methodology for evaluating, gives them the capability to make value-based judgments on the security features that they need to add in the next product increment. So this is still an excellent book and an excellent approach, even if possibly some of the terminology and so forth is more dated for a decade ago. This is still correct. And so thank you for listening. I am on the Discord. If you want to chat on the speaker stream channel, I'll be around for a while. This is kind of a summary of my talk. So I just liked this slide. There are a few more slides, I think, in my presentation. Oh, no, this is the slide. I reordered them at the last minute to cover the two books that I recommended. So I appreciate your time today, and I hope to see you on the Discord channel. Feel free to reach out.
Thank you for such a great talk, Mark. Our final talk today is String Theory, Disregarding Becomes a Dumpster Fire by Strings at 4 o'clock. We're going to take a short break until then.
Massive that place, big up on yourself.
Our final talk for today is String Theory. Disregard becomes a dumpster fire by Strings. He will detail his approach at more than a decade at being a white hat. And without further ado, I'll turn it over to Strings.
All right, I think this thing's on. We good, Trayvon? All right, cool. All right, CarolinaCon. Hi, I'm Strings, and I have a story to tell. I wanted to back out of this talk a lot. A lot of things came up, and in the end, I decided that the juice was worth the squeeze and the story should be told. So this is my story to the world about how disregard becomes a dumpster fire. Some disclaimers. In the story, I'm only speaking for myself. I don't represent any entities beyond myself. I speak for no one. I speak for me, and I try to speak for the victims. They need to be spoken for. Some of these stories have never been told outside the confines of a trusted few. Now, when we're going through some of these screenshots, you might be asking yourself, what was my intentions? Why do I keep screenshots? Well, typically I keep email chains. I don't keep screenshots, but if you don't have an email, sometimes you only have a screenshot. Point being, when you get into white hatting and you're not making money doing this thing, you're just trying to help people, your best intentions can be turned against you. So I recommend that if you go down this path, you keep proof of what you do to cover your own butt, but only the minimal amount. All right, so you only live once. Many years ago, I decided that I would try out some little yellow footprints. They seemed to fit pretty well, and so I stood on them. And you learn a lot. You grow up a lot, and you get taught the difference between ethics and morals, right and wrong, doing the right thing when no one's looking. And we call it a fishbowl. Someone's always looking. Along the way, I got to go to a faraway land, and I flew lawnmowers, real loud things. Made it through that one and got to come back home and had a little bit of money. You go places, they give you money tax free, and so I finally got my hands on an AirP cap card. At the time, things like PCI DSS and the payment card industry, it all seemed pretty cool. There were laws written down, regulations. People were going to have computer systems up, and credit card data was going to be going through these computer systems. It would be secure, right? I mean, that's how it's supposed to be. But AirP cap, this was Windows days and hadn't gotten into Linux, but you could sniff. So there I was, someplace, and I saw web traffic, and this was back in the early 2000s, and so while WEP was still being stamped out in favor of WPA, there were places WEP definitely should not be. And being that was my first ever finding, I really had no idea how to handle it. I knew something cool and I knew it was bad. I wanted to tell somebody, and so I went to a local newspaper at this place, and I was like, hey, I found something. Would y'all be interested in the story? And they seemed interested. And so, of course, being a Marine, you have to get permission from your chain of command. And so I'd worked on my paper, and I went to my gunny at the time, and I told him what I was doing, my intentions. And I got told, no, that is not my swim lane, that I was not able to do it. And so that paper, I had to respectfully decline to tell the story of what I found, even though it affected a lot of Marines. So time would go past and you go to other faraway places and you get rank. And, you know, with rank, you get privileges. You can talk to people a little bit more freer. And in one of those faraway places, the 802.11 is really common now. Wi-Fi is just everywhere, even in places you wouldn't expect it. And one of the things you learn in the Marine Corps is that complacency will kill. And a second time, I'm seeing something that's just not right. And I want to tell somebody. And so I try. And of course, I get told the proverbial swim lanes. I end up getting some negative paperwork. Yeah, you really got to stay in your swim lane. And so that pretty much marked my departure from the Marine Corps. And I got out and I got into a trade that we call information assurance. And information assurance is pretty cool. You don't really need a college degree to do it. You got to get some certs along the way and, you know, play with clearances, that fun kind of stuff. But anybody can do it. Anybody can cook. And I saw what they were asking. I said, I can do this. And so I did it and I became good at it. And I liked doing it. And along the way, well, let me see what the slide's about. I'll try to explain. So why am I even talking about this? Why am I telling my story? Everything I've done with regards to white hatting has always been in the background. Sure, some friends know about it, family. It's good. It makes for good stories, but it was never about getting famous. It was about fixing things. And in the course of those adventures, I have learned some things. And just in the last 2 weeks alone, I learned something that I wish I would have learned in grade school. And I hope to pass along that knowledge to you. So I knew I was getting on Marine Corps and I started doing contracting work and it was kind of cool. I'm still supporting the fight. I may not be wearing my uniform, but I'm doing good things for America. And having been a Marine, you learn to act and think a certain way. And when you know something's wrong, you know, there's proverbial grenades and either you're going to jump on that grenade or you're not. And you don't know until the time comes. You really don't. You can look back and say, man, I wish I would have done this or I wish I would have done that. But in the end, that grenade, that's your choice to make. So baseballs. Baseballs. All right. We already covered this. Yeah, and I do want to apologize. These slides, I've gone back and forth in my presentation. So if it seems like I'm jumping ahead and then jumping back, it's not on purpose. All right. So I exited stage left, got out, did the information assurance thing. And one day I found myself in a DC hotel room. It was a beautiful day, much like today is down here in the wonderful Carolinas. Well, wonder what's in the news. Start reading the news. Oh no. But I am in DC. And so an idea popped in my head. But before we tell that story, we got to back up just a little bit. So there I am, you know, this is backing up. This is not in the hotel room. This is years before. So I'm contracting for a living, Uncle Sam, but I'm not. Making some decent cash, supporting my family. The work's pretty easy for a coder. I mean, it's all Boolean work, true and false. Now, granted, contracting was never the plan, but it kind of worked out. It helped me to get a foothold in my field, and I'm thankful for it. I have no regrets. And then one day, we had a new girl. Her name was Tammy. Obviously, Tammy's name is not Tammy, but for our purposes, we're going to call her Tammy. And we were asking about something at work. She needed something. And she asked me, you know, how do I do this? And I'm like, oh, this and that. And within seconds of telling Tammy what had happened, her jaw dropped to the floor. And she was like, what? I was like, yeah, you click here, you click that, boom, you're good to go. No. And then she explained to me her concern, and I was like, oh, this is not good. So I had a choice. Tammy being the discoverer, I asked her, did she want to be part of the upcoming adventures that surely were before us? And Tammy said no. So I did the next thing. I went to my company that I worked for at the time, and you have security officers who deal with clearance, and they deal with this kind of thing. So I approached the company, and I told them what I found and what my intentions were. The goal was to make it to where that oh no thing was no longer the case, that this was not good. And the company was cool with it. They didn't want, not necessarily that they didn't want anything to do with it, but they didn't want anything to do with it. Understandable. Fine. So I began a journey, and I started calling people in the government, trying to figure out, well, how can I fix this? Talk to places with 3-letter acronyms: FBI, U.S. Army counterintelligence, other phone calls. Even had a couple meetings. And I got to tell you, if you have never sat in front of the FBI and been asked to type out pseudocode as far as how an attacker could do something, that's nerve-wracking. But yeah, to no avail. All these organizations, all these places where our taxpayer dollars go to protect us, the citizens, it failed. I wasn't getting anywhere. This thing was still up. Anybody could do it, and it had to stop. And so, I fast forward years forward, and in my mind, I've done everything I can. I've tried everything. I've tried the chain of command, but this grenade, it's just sitting there, and one day it's going to get somebody killed, or a lot of people killed, really. And so we look back to the founding, and tucked away in that First Amendment, you as a citizen, you have the right to petition your government for a redress of grievances. And I was in DC. I remember it. That walk was nice. There were embassies everywhere, any country on earth right there in DC. But we followed the rules. There I was at that place, and I actually had to use a get out of jail free card, because when you're talking to these people that I'm going to explain about, they deal with a lot of crazy people. And this story may sound crazy, but it was true, and it happened. And so I gave some contact information to people I trusted, and those people, they contacted those people to make sure that I wasn't crazy. And then I was told to go. And so my walk of shame began. I was alone out to sea, and I was adrift. Really let down, really hurt, but I was proud of what I did, and I'd do it again. Problem still wasn't fixed, but if anybody was going to fix it, maybe that did it. So before we talk about where this story goes, let's define loosely one of the things I learned along the way. When I first started white hatting, I would use my personal email address, something@gmail.com, whatever. And over time, I learned that nobody cares about an individual calling. But when you make up a name, you get a domain name, and it's no longer Freddie@gmail.com, all of a sudden you've almost socially engineered the person you're trying to help. Now they think you're something greater than you are, even though it's just you, but you're an organization now. And what I found was you get a lot greater impact, but you're still alone if you're doing it by yourself. Sometimes you get cease and desist letters, and they kind of wear on you. And at one point doing this, I decided to retire my organization. I didn't want to fail. I didn't want to ruin everything that I had worked for. And so I retired from it. I retired from the game. There was no more white hatting. My heart rate was a lot lower, and life was okay. Well, if y'all didn't know, Shodan.io Awareness Month was last month. And as a faithful practitioner, I had to follow the philosophy. So I dived down that Shodan rabbit hole. There's still This talked about it years ago. He's talked many times about it. So many people have done talks on this. Shodan's out there, and there's so much data, and some of what you see is so very, very wrong. And there's not exactly someone to call. There's not an 800 number to ask for help. And I got to tell you, going down this rabbit hole, quite the blast from the past. You know, remember, I'm up in DC. These memories, these things I've done, I've seen. I'm still seeing them. And this is in 2022. This is just this last March. This is not something years ago. And those webs get tangled. And there are stupid baseballs everywhere. And they will really screw you up. Extortion. Let me catch up in my notes here. So, before I get to the story of extortion, I want to tell you guys another story. While I was working on this and trying to figure out how I was going to tell this talk, a kid threw a baseball through my window, broke it, $800. And you know, I guess the kid got scared, so he ran away. Never caught him. Anyways, in one of my current cases that I'm working on, I used LinkedIn to do some cold calling. What I came across shocked me, and you know, odds are maybe some of you who are listening to this talk are affected by what's in my head right now. And I feel so powerless because I can't help you. There's not enough time in the day to reach out and contact everybody personally if they've been affected by a data breach. Maybe not yet. So anyways, there I was getting a hold of the people that need to know, and wow, LinkedIn really works. You can get a hold of people. Typically, you know, things like who is on the domain name. Everybody's got an anonymous website. You no longer get the technical department. But things were going good, and I was kind of sharing with some people, you know, my plans for how I was going to approach it, and somebody told me that my approach sounded like extortion. What? Extortion? That's a big word. So I, you know, stopped what I was doing, and I decided to do the lawyer thing and kind of read over what's going on. But you know, I'm a good lawyer, but I've got a fool for a client because I'm not a lawyer. And you know, I've always hated that about America, that unless you have a bunch of cash, you can't just call an attorney for help. So you know, we go with common sense and hopefully good judgment. Well, while I was studying about extortion, that kid happened to swing by on his bicycle. So I caught up with him, talked to him, and, you know, said, hey, we got to talk about this. So I went and met his mom and his daddy, and we talked a bit. And in the end, you know, the elephant in the room, I had to talk about my window. And I explained that, you know, I was $800 out of my pocket. You know, I need to have it fixed. I can't just throw $800 away. So, you know, and unless you guys are willing to figure out a way to, you know, pay to fix this wrong, you know, I'm going to have to file a police report so that insurance can be in on this. And yeah, they agreed to it. It was cool. So anyways, back to this whole extortion thing. You know, I realized that I am human and I don't know everything. And I carefully dissected everything I said to that person. And in the end, I felt good to go. Like, okay, it wasn't extortion. I came really, really close with my words, but it wasn't extortion. So yeah, that passed and life was good. And I'm sitting here writing the slides for the talk. And I'm happy because, you know, I'm telling story after story, and I can explain to people, you know, that one person really can make a difference in this world. Progress. And then got a knock from the sheriff's office. And he asked me to step outside, and he wanted to have a word with me. And I said, okay, sure. You know, I expect this. I've had all kind of fun agency interaction over my life. I wonder what the sheriff has to say. So I step outside, and he begins talking to me, and, you know, I'm like, okay, what? And I look at the sheriff, with a look of fear in my eyes. And I'm like, well, of course we did. Absolutely. And then they handcuffed me. Get my lawyer on the phone, and why? What was it that got me handcuffed? It was that stupid baseball. All this hacker stuff I've done over the years, all this white hatting. And in the end, it was a baseball. So let's back up and let's talk about it. Why did the baseball trap me when all the other things didn't? Now, I'm not a lawyer. I highly encourage anybody who's watching this talk, go out, do your own research, become smarter. So here's my attempt at explaining extortion. In the old days, it used to be just a government thing. Only people that did something wrong using their power of office could be accused of extortion. As time went on, it went to the common folk. So everybody can be accused of extortion. So what is extortion? Extortion can be defined as saying, your son broke my window with a baseball. If you don't pay to fix what your son broke, then I have to go to the cops. And as stupid as it sounds, that is a definition of extortion that's real. A lot of people commit extortion on a daily basis and they don't even know it. You know, upon learning just how easy it is to break the law without realizing that you're breaking the law, you have no intentions of breaking the law, I decided I would go and look at some of my emails that I've kept, you know, over the years, and how in the world I got so lucky with my words and that people never accused me, I don't know. Just the places I've been, some of the stuff we're going to cover here, it's insane. And then all of a sudden, after everything's been going right, somebody says what had been there the whole time, and I guess just nobody ever thought to bring it up to me. But again, I don't discuss what I do with people because this was never about sharing. It was about fixing the things that are broken on this dumpster fire of the internet. So yeah, if you're going to talk to people and you're going to white hat and you're going to try to do the right things for the right reasons, I want you to remember a couple rules. Rule number one, it is okay to go public about things. It's nice to go at the 90-day mark, 60-day mark, 120, whatever. It's great to structure those things so you're not putting some 0 day out there. But remember, it's okay to go public. If you know of a law being broken, it is okay to call the police. If you have been wrong, say for instance, you're white hatting and you find out that your own information, you're now a victim. You're no longer a reporter, you're also a victim. It is okay to ask for restitution where you cross the line, and where I highly encourage everybody watching this talk to really go study what extortion is and how it can apply to your everyday life. You can't cross them. Had the baseball story been real, the fact that I said, if you don't do this, I'm going to the that out of the way. So I did a thing, many of them, but with my latest lesson in life having been learned, I'm so very tired and I'm alone. And it's my hope that this talk and the upcoming things we're going to discuss motivates others out there in the community, people who may go on places like Shodan.io, and you may see nuclear power plants, you may see water companies, whatever. Instead of taking a screenshot next time, do something about it, fix it. Because what if the next person who finds it isn't as nice as you? And they do something bad and people get hurt. So why are we here? Well, it's not about money. In the many years I've been doing this, I've only ever been given a reward a couple times, and I never ask. I don't want money. That's not why we do it. We're here for us, you, me, and we. And once you agree to that, then you can be a good white hatter. When you're not doing it for financial gain, you're not doing it for the fame, good things can happen. So we're going to talk a little bit about case law, right? That this is important. What can we do on computers? For those who don't remember when the world was burning in 2020, there was a case being decided before SCOTUS, and it was Van Buren. Now I'm probably going to mutilate the story here, but I'll try to explain. Van Buren was a police officer. Van Buren also wanted to find out info about, I think it was a girl, but either way, a person. Now, Van Buren, having access to a police database, gave him the ability to look up information in a way that you, me, we, the common people, cannot do. I mean, we've got our OSINT capabilities, but you could literally, on this thing, probably type in a driver's license number and see what they did back in second grade. Well, anyways, Van Buren got caught. You know, he didn't have the authorization to use his powers for that purpose. And so it actually made it all the way up to SCOTUS. And in 2020, for the first time in a long time, the Computer Fraud and Abuse Act that has ruined a lot of lives was being questioned before the Supreme Court. And in the end, the Supreme Court came out with what we call a gates up or a gates down methodology. And the concept being that now terms of service is no longer a criminal action. So if you're out there on your web browser and you find a URL and it didn't ask you for a username or a password, well, you don't have to worry about now, did I break some terms of service? No, they left the gate open. They must want people to see. Here's where it gets really cool. Just a little while ago in the Ninth Circuit, they reaffirmed the Van Buren thing. There was a case going on with LinkedIn, and there was this entity that was scraping LinkedIn data. LinkedIn did not like that because competitors are no fun. And again, you know, I'm didn't follow the case the way I'm just reading some bullet nutshells, but the argument, as I understand it, I could be wrong, I am human, was that good for the goose is not good for the gander. LinkedIn liked Google and other search engines being able to scrape it because, say, for instance, you found a nuclear power plant open at 3 a.m. in the morning on port 80 and you wanted to tell somebody. Well, you can actually use LinkedIn to find high-level people. And so Google being able to, that's great. But when it comes to a competitor, they weren't so much of a fan of it. And, you know, while I'm sure it's going to be appealed, if I follow the case right, the Ninth Circuit just simply reaffirmed it. And so my fellow white hatters, I really encourage you at the end of this talk to go out and read about Van Buren versus the United States and to read about the Ninth Circuit LinkedIn case. It really opened my eyes and actually gave me a lot of comfort because before I was aware of this, it was always scary even thinking, man, I'll just, you know, I'm touching an Elasticsearch instance here. It ain't got no username or password, but before these cases were decided, somebody could have said, well, you didn't have explicit permission. And yeah. All right, fun part begins. So what I'm getting ready to share with the world is my story about how I landed in that DC hotel room, why I did what I did, and kind of how I made it through. Here we go. Came up with a formula a long time ago. And that formula, it's about the content and how dangerous that content is. And E, in this case, it's going to represent everybody. The M is going to represent me. And so the idea is that when you find something, if you're white hatting, and on a scale of 1 to 10, you score it a 3. Well, we're going to square 3, so that's 9. And then we're going to subtract 1, that's 8. So that means that I need to, for a 3, before I go public, because the problem's not getting fixed, I need to have 8 other people nod in agreement. Now this document in front of you, this was an easy 10, if not more. I mean, this was interesting. This was that thing that Tammy was telling me about. So, I, as a very concerned American, like I said, I tried many ways, and in the end, I was up in that DC hotel room, and that news came on, and information from the thing you see before you, knowing it like I did, like the back of my hand, because of how far I'd been invested in trying to get it shut down, I was able to read the news and correlate something that just, my heart about popped out of my chest. And I was in DC. And of course, there's delusions of grandeur in this thing. You think that you're going to go out and you're going to find this thing, and you're going to be celebrated, and people are going to be happy and tell you good job. And reality's tough. So there I am. I'm up in DC, and I'd been working this for years. This letter in front of you, it's from the past, and I'm in DC, District of Columbia. At this point in my life, aside from the people who live in the White House, I have tried everybody. I really have. And so I began to pen out a letter to the President of the United States of America, asking for help. In that paper, I outlined some other concerns that I wasn't able to get traction on, but the main talk in that white paper was the thing you see before you. The alleged security vulnerabilities, as they're called, they're really bad, and they affected me, and they affected my fellow Marines, Army, Air Force, Navy, and people who don't wear the uniform. Maybe the president could help. He is the commander in chief. So I wrote that letter. And in order to get a letter to the president, you're supposed to mail it. And even if I went first class, I mean, you got to take a step back here and understand when it comes to things like classified versus unclassified. You can have a bunch of unclassified information. And the way that we're always taught is that loose lips sink ships. And if you start talking about a whole bunch of unclassified information around the same thing, well, maybe now you're describing things in ways that other people could not correlate, put together, and maybe this should be considered secret. And so those thoughts all roll through your head when you're writing this paper. And even though I'm writing the president, I still have to be very careful with what I write down, lest I go too far. And so I got the paper wrote, and it's looking pretty good. I think it's good. I sign my name to it, print it, and I take that walk. And getting the letter to the president is hard. It's not like I can just knock at the front door of the White House and say, hey, got a letter. So I did my research, and I realized that maybe the vice president is a better way to go about doing it. You don't have reporters hanging out around the vice president's residence. And so I'm in government service at this point in time, and I went to the place where the vice president resides at, and I went to the gate where the public cannot go, and I asked him, what do you need to enter? And all I needed was my CAC. Beyond that, I mean, mentally, I knew that I needed an official reason to do so, and I had that official reason. So I said, okay. I showed my CAC and took a walk around the place. Ended up at the back gate where there's a Secret Service gentleman. Took a couple breaths, make sure I'm not going to pass out, and I go up to that Secret Service gentleman, and I explain to him that I have a white paper about the security of the nation, and I would like to have it handed to the vice president so that he could relay it to the president. And that was an interesting conversation. So time goes forward, a whole bunch of friendly people in suits come and we talk and we chat, and they're testing my letter for anthrax, and they're checking out who I am. They're taking pictures of me, and you know, this is understandable. It's understandable. And finally, as time goes on, and a little bit of trust and understanding that I'm not being crazy here, I'm really concerned. You know, I have a talk with them and I ask them, you know, is it really the case? And you know, they told me some stories about the humans that they encounter over at 1600 Pennsylvania. And yeah, I understood. And so in the end, when everything was cleared and I was cleared hot to leave, you know, asked to leave, whatever, I make my way off the residence. And I remember that day. Went out, hung out with friends, saw a movie, and we went to work the next day. And then work ended, and I come home, and I think we had a snowstorm that day. But I'll never remember it. I got that letter in my inbox telling me that my CAC had been revoked. I kind of knew it was probably going to happen, but I'd hoped that it never wouldn't happen, that it was worth it. And so, you know, that led to a series of questions, and now I'm trying to frame years worth of trying to get this server shut down into a 10-15 minute talk with this person or that agency. And in the end, nothing ever happened. You know, no laws were broken. I'm proud to say that a couple years ago, the server was finally shut down. Every so often I check it just to pinch me and make sure I'm awake. But yeah, if you're willing to push it and give it everything you got in this game, you can make a change and make an impact. But beware that not everybody's going to see things in the same light. You know, this thing was determined to be an acceptable risk, and I'm here to tell you and testify before you that it was not. And a key point before I go to the next slide is that this is the Defense Information Systems Agency. This is the people who write the rule books for how our computer systems are supposed to be connected. So who watches the watchers? I hope my fellow hackers do. So, away from the government side of the house, let's talk about white hatting. This is a story from my zone file transfer days. For those of you who aren't aware of what a zone file transfer is, you can ask pieces of the internet that run our phone books, give me everything you know about your customer. So let's say you had a domain called foo.com, and on foo.com you got a name server. Now foo, you've got a couple subdomains. You've got bud, you've got bill, and you've got bar. And bar is a really important subdomain. You don't advertise it anywhere. It's not talked about at parties. Bar is pretty important. And nobody would know about bar because you don't talk about bar on the internet. But if your name server is happily giving zone files, you find things like bar. And so this story began. So I was there doing I wrote a tool called the AXFR tools. It's on GitHub. You can find me on GitHub. And I was using my toolkit, doing research, trying to understand, you know, what fun DNS stuff's out there. And I was looking at subdomains. And while I've removed the subdomain from here so that it's not readily apparent what it was a name you just really that rip. And man, the stuff in that subdomain was so juicy. Well, I had to call somebody, and you know, luckily, this who is actually I didn't have to like do hops and loops to who is worked, and I was able to get a hold of the person. So, got a hold of them. A good follow up, you know, if you're talking to people and and they actually reply when you've sent them an email, well, you want to keep the conversation going. One, you you don't want to come across as arrogant, rude, or whatever. But two, you're making friends. You're teaching people. And that's what it's all about. So yeah, time goes on. We get it fixed. I'm testing it. I know I'm explaining to them, in this conversation that, thank you for listening. Thank you for taking the time to listen to what I had to say. Because that other IT guy said, oh, it's fine. It's cool. And, you get sometimes you get a little bit of insight as to why. It's always cool for the follow-ups to understand, well, what exactly broke on your end? Because all I know from my end is that it's vulnerable. And so it's all about that trust and that building. Well, time goes on, and over here on the third piece, excuse me, this person is asking for something very reasonable. Do you got records? Well, what I didn't explain in the screenshot was that since we're not talking over email, I'm obviously going to keep the email chain. Anybody who white hats, I said it before, I'll say it now, keep your evidence. Don't keep the findings, but keep your evidence. And so I'm explaining to him here that, I don't keep records. But then, I wanted to double check, like, okay, this is DNS. I love my work on this distributed database. Let me see what's up. And crap, his domain zone file was uploaded. And so I had to break it down that, hey, it's what I found is not out there, but how I found it kind of is. And so that's it. That's where that left off. Good lessons were learned, and strings are fun to read. This story. So this is another DNS story. And what had happened here was that I was doing, I don't remember if I was doing a reverse scrape or if I had come across company A, but either way, I had determined with the data I had on hand that this name server was providing resolving for multiple domains. This was, how do I tell you guys this without not explaining who it is? This wasn't a telco. It was kind of like a GoDaddy or something along those lines. GoDaddy probably works for the explanation. No, this is not GoDaddy. So anyways, it's you got this company, they're running DNS and they're records for everybody. And the way that I wrote my transfer tools, I could do reverse queries. And I was like, well, all right, you're querying for this guy, for that guy, for that guy. Well, what about yourself? And I asked the name server if it was querying for itself, and sure enough, it was. And so, when I saw that, I'm like, okay, rather than having to contact, X number of companies about this name server problem, I'm just going to contact the company that's causing the problem, explain to them, hey, your clients are vulnerable, but so are you. And it works out, the original email is not shown, but down here they're asking for details on how it's exposed. And this is exactly what I, as a white hatter, want to see on the first feedback from the person. I want them to ask those questions, because if they don't ask those questions, they may not fix it correctly. And so, hey, what's exposed, break it down here. And then there's further emails, but needless to say, we got this fixed in a very reasonable amount of time, and I'm quite proud of how it turned out. And victims were saved. DNS really, you really can, if you've got a zone file, you've got some keys to the architectural kingdom. Then you got screen doors on submarines. Now, the next slide is also a piece of this, but I was in college trying to get a degree, and I was doing something, and a piece of the college's infrastructure itself was vulnerable. And y'all have to forgive me. I have to be very careful to not expose some of this. So this thing that was vulnerable, it actually led me to find what I'm going to show on the next slide. But the key takeaway point here is that, as you proceed doing this, sometimes you're able to get a hold of the right people that you can call at 2 a.m. if you find something else, and your ability to make a positive change on the internet grows when you get conversations like this going on. Because I guarantee you, if for whatever reason I came across something on this domain in the future, I can contact this person and be like, hey, this is me. And rather than have to jump through the same hoops that I did the first time, you just leverage that past actions and hope they speak for you. And so, like I said, this vulnerability would lead me to another vulnerability. And I call it the ye old watering hole attack. We read about them all the time. You hear, especially in the government world, the congressional staffers at the bar and spies and all. So I found myself in a situation in college where there was a watering hole attack and everybody was vulnerable. But it wasn't because they were running their mouths. It was because cookies run their mouth for you. And what had happened here was that the way that this infrastructure was tied together, the cookies did not have the secure flag. And so for my fellow hackers that know what that means, what I could do is I could induce a scenario using Wi-Fi, and I could make everybody's computer, if they're sitting there browsing and I happen to catch them a certain way, which is really easy, it still is, it's packet injection. TCP is fun. My response to their computer would be interpreted by their browser as legitimate directions from the server they were trying to contact. But because it's packet injection and how that works, I'm able to tell the computer, no, instead of that, I want you to show me some cookies. And so you convince their browser to spit out the cookies, and now you got cookies. And remember, it's college. And so a lot of bad situations could have occurred from this. This kind of a watering hole attack had a real stalker, creepy, scary vibe to it. And so the takeaway here is that when I was writing this specific paper, I had to be real careful with my words, and I had to make them strong enough to where the people reading it would be like, wow, that is super creepy. We need to change this as soon as possible. And so there's this big long white paper below this, but the cool part about this is, at this point in time, this is probably, I don't keep numbers, especially from the early days before I started learning to cover my butt legally. So this is probably easily my 90th white paper, whatever. And Bitcoin was a thing. They gave me Bitcoin. Sadly, the Bitcoin wasn't worth that much back then. And if I had only hung on to it, but what you gonna do? Another point here to take away is, to this person, if you're watching this video, thank you for the reward. When you reward people for their actions, it inspires them to go forth and conquer even more. So thanks to that person if you're watching. Moving on. Gotta love some Shodan. So without getting too deep into what this is, needless to say, you don't want port 3389 open on this machine. And it was such a striking, oh my gosh, is this really? This has to be a honeypot. Got to be a honeypot. So I reached out to the organization, and it took a little bit of time, as it always does. And I got a hold of the right person, and we're talking, and I asked him, you know, is this real? Is this a honeypot? What is this? And it was not a honeypot. And so I'm very thankful that I was able to get a hold of the person, and they were thankful too. This was one of the funner ones. So Wi-Fi. People wouldn't think that you can have a kinetic reaction. Well, it just so happens you can. You can, if you know what you're doing with Wi-Fi, you can easily trace people. And I know, right? I can hear it. The MAC randomization. No. There's ways to de-anonymize that, and that's its own talk for a different time. So this police department, I'm not going to say where, was using WEP. And I left the timestamps on purpose. This is in 2020, a police department. They're using WEP, wired equivalent privacy, something that somebody with an N900 and 3 minutes worth of spare time can hack. So I started making phone calls, and I'm sure y'all can understand that calling the police department and saying, I can hack your network, that is a conversation that's, you definitely remember it. But you know, in 96 hours, 4 days worth of time, I wasn't able to make the case that this is really bad, like your officers' lives are in danger. And so I did what I normally avoid and shun, and that I went public. And I found out when the town, city, entity was having a board meeting, and I'd already given the police chief a heads up because I knew that even speaking about it, who knows what somebody's going to do with that info until it's fixed. There's still going to be a gap from speaking about it to when it's fixed. And that was the time to be worried in. And so, you know, I try to be nice to give the police chief a heads up. I went before the public, and I told the people who needed to be told. And I'm proud to say that I didn't end up in handcuffs. Nobody accused me of anything. And as of some time ago, I drove past that police department, and there is no more WEP. So yeah, if you administrators are out there running places like police departments or hospitals, whatever, and you're using cyber and you're using technology that's really old and really outdated, update it. It's not worth the life of a human because you were too cheap on your budget to go from WEP to WPA. Humans are worth way more. This was a fun one. Needed to change the password to an account one day. I'm sure many people here have done that. So we got a pair of bills, so we go to change it. And I get this lovely email in my inbox. And there's a couple things to point out here. They're telling me my password, so that's no good. They're telling me some great advice here. For account security reasons, you should delete this email. I just want to strangle it because, you know, for account security reasons, the email probably should have never been sent, not in its current form. The last piece takeaway is, you know, now granted this is 2014, so SSL strip and all that fun was still all the rage, I'm sure, but you know, when's HTTP gonna die? I hope the power turns on every day that I wake. This is the kettle meeting the pot. So with this story, what had happened was I found something, and they have a place where you can report issues. So I clicked the button, and anyways, you create an account and they shoot you an email. Now this is I'm trying to tell the people about a security problem. These are the security people that run this thing. And All right, HTTP, cool. My password, cool. And this is the stuff you see, and it's frustrating. Lastly, to the organizations and people who may be watching who are in a position of power that allows you some say over what your customer service representatives say and do. I want to take you back to this night. This is April 12th, so not too long ago. And it's late at night, and I have discovered a very critical piece of the internet exposed in a way that it should not be exposed. And this is something where you wake people up. And so I made some phone calls, and I'm talking to somebody, and I'm trying to explain to that CSR that this cannot wait. It's so important. So I need to speak to somebody. I can't just have you pass my message along. And in this situation, no matter what I tried, sometimes you're still going to fail, no matter how good you are at talking with people, putting your words together. So I ended up getting told to shoot an email, and I did just that. And for this email, rather than send from a custom domain, I even made a Gmail just so that I knew it would get there with no problem. Still, my email that was very important, according to this person, it made it to the spam bucket. For whatever reason, luckily they decided to read their spam bucket a couple days later, and they were able to get hold of me and fix things. The failure here was that in all my comings and goings of doing this, I've only ever had a handful of interactions with CSRs who go above and beyond that call of duty for their organization. If you have CSRs and they're on the phone and they're talking to people who could be your customers, it could be future customers, or it could be some dude like me just wanting to do the right thing and found something. Train your CSRs to where they understand if somebody calls in and they start talking about a cybersecurity vulnerability, that maybe there needs to be a new script. Maybe things have to change, because had this one gone to the spam bucket and never been seen, this really scary thing that was public may have taken a lot longer to be fixed. And that just not cool. That is my story. I hope everybody has enjoyed this story. And I hope that it brings to light to those of you who may know me and wonder, what is it exactly I do? I'm a white hatter, and that's what I do. That's it.
A special thanks to all the speakers today. We hope everybody can tune in tomorrow for the remaining talks. Trifecta of Email Authentication by Dennis at 10 a.m. and Beyond Purple, Fostering Cross-Team Collaboration by Andrew Clinton at 11. After those talks, we'll be having a live stream where we will take questions about the CTF and answer some general InfoSec questions while building this year's badge. We hope to see you then.
Straight from the grain, I'll be giving you your pain. Straight from the grain, I'll be giving you your pain. Anger, coming from the 36 chamber. Straight from the grain, I'll be giving you your pain. Anger, coming from the 36 chamber. green. Anger coming from the straight from the green. Anger coming from the 36 chamber. Bang.
So no one take it personal. Send for the new gun. New gun. New gun. So no one take it personal. Send for the new gun. So no one take it personal. Send for the new gun.
Play off all of the educated, sophisticated girls. Take you on the world, diamond and pearls. Watch this. Woman of your body, woman of your shape. Woman jump above for the body, look great. Woman of your body, woman of your shape. Woman jump above for the body, look great. And in the ear because you have good taste. It's not just your body, me say now your pretty face. And in the ear because you have good taste. It's not just your body, me say now your pretty face. It's not just your body alone, it's not just your shape alone. Education, girl, you have it plenty. It's not just your body alone, it's not just your shape alone. Education, girl, you have it plenty. All the ambitious girls, yeah, in a good condition. No man can use it for a one night function. What is? Woman of your body, woman of your shape. Woman jump above for no body, look great. Woman of your body, woman of your shape. Woman jump above for no body, look great. And in the ear because you have good taste. It's not just your body, me say now your pretty face. And in the ear because you have good taste. It's not just your body, me say now your pretty face.
Tonight, you are going to hear music you never heard before. Tonight, you are going to hear the most cantankerous, roughneck, poisonous dubplate you ever heard.
Follow me now, master, follow me now. Special dedication to all the woman. Follow me now, master, me say follow me now. Yeah, you want special dedication. Special dedication to all the woman. Follow me now, master, me say follow me now. Yeah, you want special dedication. Follow me, follow me, follow me now, master, me say follow me, follow me, follow me now, master, me say follow me, follow me, follow me now, master, me say follow me now. Special dedication to all the woman.
Those lights. Those lights. Those lights. 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 Those lights. 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 Some things come over my soul.
my soul. Out of my control. Something come over my soul.
So listen to Kanza Manchunia. So listen up. So listen to Kanza Manchunia.
What you doing? What you doing?
I want to see all the hand them in the youth like this. So listen up. And in the air. And in the air. So listen up.
Run them, run them, run them, run them, run them. I know it's the way the original arsonist. Anytime we send for the fire,